welcome to the VMUG UserCon. Now I'm going to skip through a few slides. So VMUG has a number of different communities that you can participate in. And there's special interest groups or communities for specific things. So you can participate in the Toronto VMUG group, or you can also participate in online forums for different groups around the world if you want to participate in other areas. So you always have that online capability of doing that. But if you want to focus on certain types of technologies, such as NSX, or they just created a new community recently, which is around vRealize and software-defined data center. So that was just announced very recently. Lots of interesting talks and dialogues happening on that community right now. So again, through the community's website, you're able to go in and sign up for each one of these different special interest groups and gain a lot from the forums. There's also a section on the website which is geared towards education and really helping the community grow their career and expand their knowledge base. And if you are a member of VMUG, you can get discounts on courses. So let's say, for instance, if you were to look at the vSphere 6.5 install configure manage course, the regular price would be around $4,125. That's retail price. If you are just a VMUG member, which means you signed up, you didn't pay anything for it, you just signed up and said you're a member, then you automatically get like a $600 discount just for being a member. So it's fantastic to do that. It really saves you a lot of money. All you have to do is just go up to the VMUG education site, click on that, and then you can sign up through the VMware education in order to take those courses. Now, if you're a VMUG Advantage member, then you save even more money. So the cost of a VMUG Advantage shows up over here. For a single year, it's $200 US. But if you look at how much you actually save, you make that money back right away on the first course. So if you're doing any kind of training, sign up for VMUG Advantage, you'll get your money back right away, and you'll get all the benefits of the VMUG Advantage. And one of the benefits of it are 20% discount on classes, discounts on certification exams, discount on VMworld attendance, and you get special training and opportunities that you can get just from being a member of the VMUG, or sign up for VMUG Advantage. One other thing which is really fantastic is the eval experience. So if you want to create a home lab and work with some of the technologies that are available, sign up for VMUG Advantage, and then you get all these licenses. So you'll get vCenter Standard, you'll get vSphere Enterprise Plus with operations management, the vCloud Suite, vRealize operations, the list just goes on and on and on. And this is good for, I believe it's 380 days. So every time you renew your VMUG Advantage, you basically renew your licenses. So the amount of software that you get, that alone, it really helps things out. So I definitely recommend doing that. So I'll jump into some of the updates that were announced over at VMworld. There's really quite a lot that were announced. So I'm going to give point form on some of the major ones, and then if you want to talk about them or drill into them a bit more, I can do that. But I'll just go through the main points. So one of the big announcements that they had over at VMworld was VMware Cloud on AWS. Now, what that actually is bare metal servers running vCloud Foundation. So you have your vSAN, you have NSX, you have all flash SSDs running in AWS. And you're able to expand and contract on the fly just like you can with cloud resources. And you only pay for what you actually consume. So if you need to increase the amount of compute for a short period of time, you're able to do that. You simply just add more compute. It creates a ticket over with AWS. They go in there, and I believe it's in under 60 minutes. They get the new compute node in there, connected over to the rest of the environment, attached over to the vSAN, and they manage all the updates. They manage the operations of that whole infrastructure, so you don't have to worry about the back end. It's not like you're managing your on-prem and the cloud infrastructure. They manage all that for you. So it's presented to you as a dedicated, 100% dedicated hardware platform that's fully managed for you. And you basically just pay for the amount of utilization that you have on it. This is also able to tie into your local on-prem environment. So by using NSX, you can create a stretch layer 2 from your on-prem over to the cloud. You're able to move workloads in between them. There's lots of really interesting things that you can do. You can also make use of all of the different things that are available in AWS, such as load balancing, Red 53, all the different services that are available to AWS. You're able to access those natively without any transit fees from within this environment. Now, right now, they've rolled it out, and it's GA. They only have it available in the West Coast and Oregon. That's going to be for a few months, and then they're going to start rolling it out over to other regions. So you actually can get it right now, but it's just in that one region. The next thing that they announced is VMware Cloud Services. And a few months back, VMware made an acquisition of a company called Wavefront. Wavefront allows you to do cost-based analytics on different cloud providers and on-prem and so on, so you can understand exactly how much you're actually paying for an environment, and you can do calculations and determine what makes more sense, whether you can put some workloads in the cloud, whether you can have it on-prem, and whatnot. They tie this into other services that they have, which provide traffic monitoring metrics, and utilizing NSX, you can have layers of security across the entire environment. So VMware Cloud Services ties all these things together and then offers that up as a service over to people who want to have workloads on-prem and in the cloud. VMware Cloud Foundation is essentially SDDC. This is the latest revision of it, using vSAN 6.6, the latest version of NSX, all the latest components. This is essentially what's going to be used as the standard for everything that is VMware going forward. The integration of all these different components of the hyperconverged storage, of the software-defined networking, of all the policy-based structures that you have within the environment. VMware Cloud Foundation is the core of all that, and that's actually what they use in VMware Cloud on AWS. So you're going to be seeing a lot more of that in the future. VMware NSX now supports networking and security for cloud-native apps, so you can run NSX to do microsegmentation of containers. So you're able to have mixed workloads of traditional VMs as well as cloud-native VMs, and you can use NSX to do the segmentation of all these different types of workloads. Next thing, they have released the newest version of VMware Integrated OpenStack, version 4. This allows you to run containerized applications along with traditional applications within OpenStack. So just as I was saying before with NSX, you're able to do the same sort of thing with OpenStack. So it increases the breadth of the capabilities that you can do within OpenStack. vRealize Network Insight. If you haven't played with Network Insight yet, you can download it. You can use it to determine what your network looks like, what kind of benefit you would get from doing microsegmentation. You can do analysis and create a report. It's really, really brilliant. What it allows you to do is look at all the traffic, look at the different paths of where it's going, understand how your network topology is set up, and really, really dive into the weeds to understand what's going on your network. It's a fantastic piece of software. That's actually from another acquisition that VMware made within the last year. So there's been quite a number of acquisitions that have really increased the portfolio, and VMware has been piecing these together so that it's provided as one complete seamless platform. Now this one's really interesting. It's the VMware Hyperconverged Infrastructure Acceleration Kit. So now you're able to get vSAN and put it onto 3 vSAN ready nodes, and you get a vSphere standard, you get a vSAN standard, and that whole cost for that is only about 7,000 or so US. It's probably not too much more in Canadian now because the dollars are pretty similar. But before, that would have cost you an incredible amount more. That probably would have cost you about $10,000 a node in the past. So they've dramatically reduced the cost. The constraint of this is that with the HCI acceleration kit, it only allows for 1 socket nodes. So it reduces the total compute per node, but it allows you to put unlimited VMs on that. So as long as you have a smaller environment and you're not going to scale up, or you have very specific use cases for this, then this really makes a lot of sense, and you can save a lot of money by putting this in place. The use cases that they're targeting are for branch offices, for things like in the military, having mobile workstations, for IoT networks, that sort of thing. That it's not necessarily going to grow inside, but it's going to be distributed throughout many different locations. In the past, the only thing you could really do that was similar was to get a robo license, and that would allow you to have up to, I think it was like 25 VMs across the board licenses. So this really goes far beyond that. You have unlimited VMs that you can have in the environment, and you pay a fraction of the original amount. So if you take the cost of the vSAN ready nodes as well as the acceleration kit, they say that the total cost of a solution of this would be under $25,000. So that's pretty good if you want to deploy a resilient hyperconverged infrastructure. VMware has also announced a scale-out edition. So they have a new version of vSphere that incorporates distributed switches and some other features like that to allow for high-performance computing and big data clusters and that sort of thing. So it's a specific edition specifically for that. VMware Validated Designs 4.1 is now out now. So if you want to get all the details of what you need in order to build a BOM, all the components, everything that's supported, looking at the HCLs, so you can really dig deep into an architecture and say that, okay, this is validated, this has been proven, we can take these exact things and we can build that out. It reduces the amount of time in order to build up reusable environments in architectures. Now, this is a big one. VMware Updates. This is a new offering that VMware has, which is part of their security framework. That what it does is it actually looks at the applications that are running within a guest OS, and it will determine what is the intentional state, what's an anomaly, what's actually going on within the environment itself, and then it can do things such as quarantine applications or tie into other things like Puppet and respawn configurations. It can do a lot in order to ensure that there's no changes that are done to processes or environments and that they're running. Yep.
Is this machine learning? Is it based on machine learning?
It does use some form of machine learning, yes. So it's able to determine the behavior of the applications, and then based on that, it will action and remedy it to ensure that the environment stays in the state which was predefined. So you're able to whitelist certain processes, applications, and say these are what I want to run on the network, as opposed to blacklisting other ones. So it's an increased level of security that really ensures that nothing changes within your environment unless you actually say so. So it's really quite interesting and advanced. I'm not going to go into too much, except I strongly suggest that you look at some videos that are right there. You're going to be hearing a lot more of about app defense. And I actually spoke with one of the local VMware certified instructors that deals specifically with NSX and app defense, and we're going to get them out here for the next VMUG that we have, so that they can do a full session with you guys on that. And next thing is that NSX-T or NSX Transformer is now released as well. It used to be called NSX-MH or Multi-Hypervisor, which it allowed you to have it on Hyper-V as well as vSphere, and there was two different code bases for NSX. There was the NSX-V, which is for VMware, and then there was the NSX-MH, which was the multi-hypervisor. And they had two different code streams. They now unified those together so that you have a single code stream across all different platforms. And this is going to allow them to further the deployment and the spread of NSX by having it in AWS, Azure, Hyper-V, all the different places that you can think of, so you can create a cohesive network across your on-prem environments, regardless of the hypervisor, and your cloud environments, regardless of the cloud platform as well. And that's all I have for VMware Updates. Anybody have any questions on VMUG or any of the updates that I can talk to?
This question about security layer. It's required VMware tools because it's working with operation system.
And there is an agent that gets deployed within the guest for app defense, so it can do guest introspection. Now, I believe that there's some aspect of it that does use the tools, but in order to get the full breadth of the product, there's an agent that needs to be used.
That HCI solution that you mentioned there, can you add additional nodes to that vCenter, or is it capped at 3 nodes?
Well, it says that it is a standard vCenter server,
Okay.
so that's not capped.
Yeah.
Now, previously, vCenter Foundation is the one that was capped at 3 nodes. They've actually increased the limit on Foundation now to 4 nodes.
Okay.
So for the Essentials Plus and that sort of solution, that would make me assume that they're going to increase the number of nodes available for that. But for the HCI acceleration kit, we have a standard license. So that standard license is good for vSAN on those 3 nodes.
Yeah.
You can add other hosts to it and connect over to the vCenter.
It's just a separate license.
Exactly. So the a la carte license.
Yeah.
But that allows you to scale out and not throw out the licenses that you already have. Previously, if you had Essentials Plus, you had to upgrade over to standard in order to add more hosts. You don't have to do that with this because you already have Essentials.
Yeah.
All right. Then, without further ado, I will present Pure Storage.
We'll be careful.
Okay.
Right. Stand on the other side there.
Yeah, that's probably best.
Does that look? All right. Hey guys, well thanks for your time. So my name is Dan Cogan. I'm a local systems engineer here for Pure Storage in Toronto. Joined up here with my colleague David Burns. And we have some of our colleagues in the back as well, I note. Daniel Sobek and Raymond Faxon, and also some local systems engineers here from Pure Storage. What we wanted to do today is talk about Pure Storage and why it is the data platform for your digital business. Got a little bit of an agenda here, so we're going to talk about the data platform and what encompasses it. We're going to talk about FlashArray, which is our flagship block-based product for iSCSI and fiber channel connectivity for your VMware workloads. We're going to get into the integration that we have with VMware. We'll talk about FlashStack, which is our converged infrastructure with our partners at Cisco. We'll talk a little bit about the FlashArray X, which is our newest product, which is based all on NVMe media as opposed to SSDs. And if we have time, we'll talk about FlashBlade. It's not necessarily VMware related, but I'm assuming you guys do something other than VMware sometimes in your work. This is our analytics kind of big data platform as well. We're going to touch on it if we have some time. So basically, our data platform really enables your digital business to deliver the speed that you need for your business applications, giving you faster time to market, the insight that you need by analyzing all your big data in real time as opposed to post-processing, which happens a lot of the times on a slower platform, and the agility to give you hybrid cloud scale, right? And we'll talk a little bit about how our platform, because we're a newer generation storage platform, the API, the CLI, and the GUI all have feature parity, so enabling that agility through automation.
How many people here have actually heard of Pure Storage before this? Oh, that's great. And how many people have a good idea of what the value prompt is? What's different about Pure Storage? Okay, good.
So just a little bit of background on where we are. So this just came out, I believe, in July. So it's the fourth year in a row that we've been in the Leaders Quadrant for all flash arrays. This is something we're really proud of. We've only been shipping product for 6 years. 4 out of those 6 years we've been in the Leaders Quadrant. The guidance from Gartner is you can't compare previous years to this year, but if you were to look at some of the years back, we've moved further to the right than everybody else from an innovation perspective, and we're closing the gap between us and our closest competitor on the execution stage, which is our ability to obviously execute and get more of our flash arrays out of the field. Customer satisfaction scores are the highest in the tech industry and some of the highest in the world, period. This again is a big improvement over our scores from last year, which we're really proud of because we introduced a new product, so we talked a little bit about the FlashBlade. Usually when you introduce a new product, that doesn't always necessarily bring your scores up. It's new, it's a 1.0 release. We actually brought our product score up by 0.7 from an 83 to an 83.7 with introducing a net new product in January. And our support score actually went from 90 to 92. So we're making sure that we maintain our customer satisfaction levels, our industry-leading customer satisfaction scores, even while introducing new products to the market.
So 1 second here, I'm sure you've had other vendors talk to you about how they have these really high Net Promoter scores, etc. You've seen this before. What you want to ask any vendor who tells that or says that to you is, are you certified? So what that means is, if you look here, these scores are actually a certified score by Satmetric. So anyone could say that I have a customer satisfaction score of 1 billion because I'm so awesome. But that's them calling their favorite fans and saying, you still love me? You do? Great, checkbox. What this is an audited score. So to put this into perspective, we have the highest scores in technology, period. We actually surpassed Tesla to be able to make that claim last year. These satisfaction scores here are higher than Starbucks. So we're going to talk a little bit how we achieve that.
And to give you some context, this isn't coming from just people you've never heard of. I mean, these Satmetric scores and these customer satisfaction scores are coming from obviously some well-known companies in the industry. Let's see if my pointer works here. Some relevant ones here that the NHL, again, that we're all Canadian. The town of Milton, some of you might even live there. They're a very satisfied Pure Storage customer, and we're Northbrook General Hospital. We have create somewhere. So some relevant Canadian logos up there as well, who obviously participated in our customer satisfaction scores. They would be happy to talk to you about their experience if you want a customer reference.
You just wanted to show up that.
I know. So without further ado, we're going to talk about FlashArray. So this is our flagship product. We started shipping this in 2011. basically it was built on three real simple things. We wanted to make sure that it was effortless, we wanted to make sure that it was efficient, and then obviously our most disruptive thing that we brought to the market, which is our evergreen storage program. What do we mean by effortless? Effortless means it needs to be reliable, right? You don't want to have to be spending your cycles worrying about storage. And so when we talk about reliability, people talk about how many nines, right? So obviously we're on the far end of the spectrum here with the 6 nines of availability. One thing that's really important to note is that there's no asterisk up here, right? A lot of times when people publish their nines of availability, there's an asterisk and it says, well, that doesn't include scheduled upgrades, and it doesn't include hardware upgrades, it doesn't include software upgrades. We don't leave anything out of this window. So this means that even through generational transformations of changes in architecture, or if you're upgrading to a new performance profile of your flash array, we don't leave that out of the window. Even with our software updates, they're all done completely non-disruptively, meaning that you don't have to take any of your workloads offline to move to a new hardware generation or a new software generation. So it's only 31.5 seconds of downtime per year. When you look at the difference between 5 and 6 nines, right, going from 5 minutes to 31.5 seconds, that's a big difference, right? Because when you look at that 31.5 seconds, you extrapolate that over a decade, you're basically only getting 5 minutes of downtime in a decade.
So there's lots of things about our story that we joke about. We say we get BS face. People don't believe that we can do what we say we can do. This is one of them. So we're saying 6 nines of availability on 2 controllers. If you talk to our competitors, they're actually going to say, well, they only have 2 controllers. There's no way they do 6 nines. We're going to talk about the architecture and how we actually achieve this. And to Dan's point, it isn't just reactive. This is also proactive work as well. All of your upgrades, transformations is what we call it. We're included in that number.
Yeah, and to give you just a little bit more context of where those metrics came from, 96.6 of our arrays have had 100% of uptime over the last 3 years. Right? So that's what contributes to a lot of these things. Effortless is also, this is always been one of my pet peeves when I was a storage admin, was having simple management tools, right? My biggest pet peeve was having to stand up infrastructure to manage my infrastructure, right? You get your new storage array, and what's the first thing you need to do? Oh, I need a database that's going to connect to my management console, that's going to run on a VM, et cetera, et cetera. You buy your 100 terabytes, 1 terabyte of it's already gone before you've even put any business-facing applications on it.
I'm just going to pass this around. This is our app that actually is showing some management of the array. You can actually go through. This is someone's array showing where we are from capacity, latency, IOPS, bandwidth, and overall load on the array. So feel free to pass that around.
Yeah, that was on one-click buy.
No.
So this is both the local management of the array, so that over here that you see on the left is the web-based management interface for the flash array itself. No Java required, simple HTML5 enabled browser. You point into the management address of your individual flash array, and everything that you need is right there at your fingertips with single click login. On the other side, when you get into managing multiple arrays where you want to start getting into now your forecasting or capacity planning tools, that's also simple HTML5 enabled browser. It's all SaaS based. So when we release new features, all you have to do is log out, log back in, and you get those new features, right? You don't have to worry about, oh, do I have the right version of SQL and the right version of Windows and the right versions of all this other stuff to be able to take advantage of those new features. And oh, by the way, who's going to do that upgrade? Do I need professional services? It's all included in your maintenance costs. And you don't have to manage any infrastructure to manage your infrastructure. And we talk about efficiency, right? So you think about when Behr first came to market in 2011, 2012, Flash, so we're all Flash platform, right? We've never made a spinning disk product, so it's all Flash. You can imagine that in 2011, 2012, Flash was much more expensive than spinning disk. Things are starting to equalize a little bit more, but still more expensive. The good thing about that is that it forced us to come up with industry-leading data reduction technology. And so what that meant is that compared to our competitors, if you need 100 terabytes usable, you're probably used to what you're seeing on the far left, which is, okay, it's going to format down, and if I turn on YouTube, it's going to degrade performance, all this other stuff. You have to buy about 125 terabytes raw to get your 100 terabytes usable. Some better scenarios, 1 for 1, 100 terabytes, maybe 99 or 53. With us, based on our average data reduction, you get a 5 to 1, which is what you'll see typically in your VMware environments for general purpose virtualization. You only need to buy 35 terabytes raw. So with our industry-leading data reduction technology, that will give you 100 terabytes usable for your general purpose virtualization.
So the reason we do this, or are able to do this, is that we do data reduction at a far more aggressive way than everyone else in the market. First of all, we do it at the 500 byte level. If you look at our other competitors, the next smallest would be 4K, and there's only one competitor that does that. The rest are 8K block sizes. So we do it at a very, very granular size. The other reason is we do 5 passes of data reduction, compression, deduplication, and pattern removal, inline and post-process. So that's how we're able to achieve these numbers.
Important thing to note is that all of our software features are on all of the time. So when you look at some of the performance numbers that we're going to publish, that's with everything turned on. So you don't have to suddenly worry about, oh, I want to enable dedupe. What's that going to do to my performance profile? It's always on all the time. You cannot turn it off. Right? So none of that is going to influence the performance profile that you get out of it. If anything, it actually improves. And then Evergreen. So this is really, when we talk about changing the storage industry, this is really what Pure has done. Right? I mean, a lot of people are trying to emulate this or copy it. Imitation is the sincerest form of flattery, so we're honored. Made up of these 6 components that you see up here on the board. The first one is Forever Flash. So this is really Pure's way of breaking the maintenance extortion model. Right? So if you've ever purchased storage in the past, or some hardware in general, what happens is that you buy it for 3 years and it includes the first 3 years of maintenance. When that 3 years comes up, your friendly neighborhood storage vendor comes up and says, hey, guess what? Your maintenance is up. And hey, this thing's old now. So your maintenance is going to cost you way more for year 4 than it did for years 1, 2, and 3. We said, that's not necessarily the right way to do it. So what we said is like, look, you buy a Pure Storage flash array, you're going to buy your maintenance for the first 3 years. When year 4 comes around, or year 3 ends, we're going to come back and we're going to say, do you like your flash array? Based on all this other stuff, you're going to say, yeah, it's great, I love it. Okay, great. Your maintenance for the next 3 years, so for years 4, 5, and 6, is going to cost you the exact same that it cost you for years 1, 2, and 3. So long as your capacity hasn't changed, right? So if it was that 35 terabytes raw and these are 100 terabytes usable, what you pay for maintenance in years 1, 2, and 3 is what you're going to pay for years 4, 5, and 6. On top of that, what we're going to do is that because based on that dual controller architecture, we can provide 100% of our performance on just one controller. We're going to come in, we're going to give you the latest generation of whatever controller model you have, which is going to have a new Intel chipset, right? Which is going to have obviously a faster processor, potentially have more memory in it. It may even have new fabric. We may have gone from 16 gig fiber to 32 gig fiber. We may have gone from 10 gig Ethernet to 40 gig Ethernet if you're using iSCSI. You're going to get all that, all for the cost of your maintenance. There's not going to be an upgrade charge. That's included in the cost of maintenance. So this is what we talk about getting rid of that maintenance extortion. On top of that, we call it flat and fair. So what that means is that that number is a do not exceed number. That number might actually go down. If we get better at doing what we do from a maintenance and a support perspective, and we find that it's cheaper for us to provide it, we will pass those savings on to you as the customer.
So to make this seem more real, we actually could sell you today 12 years of maintenance up front. There's no other storage platform that can do that. Because, you think about it, you would have to stock parts for 12 years to be able to take care of the array that you just sold 12 years of maintenance on. With Pure, you don't have to worry about that. Now, I'm not saying that buying 12 years up front makes sense. I'm only telling you that to showcase, like, this is real. Your costs, from a maintenance perspective, are going to be flat and fair forever.
Last example on that is that we had a customer that Dave and I sold to last year, and we were in a fairly competitive situation, and the differentiators really started to stand out. The one differentiator that sealed the deal was, okay, if you guys can put it in writing, in a contract, we're going to buy 6 years of maintenance up front. If you can put it in a contract, what my 7, 8, and 9 years maintenance is going to be, we will buy your platform, and we were able to do that. Nobody else was able to give them anything past year 5. Right?
We started doing that as default now. We'll show out-year maintenance for, I usually show right up to 12 years. So from you as a buyer, you're actually going to understand what your out-year maintenance is going to be in year 79, or and longer, if you wish.
So that's Forever Flash. Again, sorry, question.
Just thinking pragmatically here, if you buy 35 terabyte today, in 4 years' time, if you do not exceed that, then you oversized back then, so you're kind of out of the contract. So I appreciate what you're saying, but to think that we could extend over 5 years and not any data growth. I mean, I appreciate the sentiment, but
well, and that's
what
why.
does it look like when you break out of the contract?
Absolutely. So every incremental add of capacity does come with additional maintenance costs. We can give you that up front, so we can give you what that would look like with a 10 to 25% year-over-year growth. And again, that would be a do not exceed number. Right? So
we
understand.
Very popular in municipalities in certain aspects where they don't control the operating exposure
Yeah,
over
yeah.
a long period of forecast that. The reality is very different.
Oh, absolutely. Absolutely. Right? I mean, it's kind of funny that Dave and I joke around that we're actually horrible salespeople sometimes, because people are used to buying storage in that 5 to 6 year chunk because they're not sure what's going to happen with the compatibility of new technology on the platform as it comes out. So we actually suggest to most of our customers that, like, unless there's a benefit to you in buying 6 to 9 to 12 years of maintenance up front, don't, because the cost may actually come down, right? And you're kind of locking yourself into something when you don't need to, right?
Absolutely.
Like if your new capacity, if you only need 35 terabytes for today, and you know you're going to need 100 later, well, buy it as it comes out. With Moore's Law, we know the media is getting denser, it's becoming more performant, it's getting cheaper. Because of the way that we're modular, we usually suggest don't buy what you need for the next 5. Buy what you need for the next year or 2, because it's totally modular, we can add it as you need.
So we don't even call it maintenance internally, we call it a subscription. Because we actually operate more like a SaaS. Yes, it's physical hardware, yes, it's going to be on-prem, all of that great stuff, but we operate more like a SaaS model, where you pay that subscription to innovation, we call it, you pay that annually or every 3, and as a part of that, you get new controllers every 3 years, and you get all of the software that we make, not just the software for today, but software for the future too.
So the second part of this is the right size guarantee. So one of the challenges, obviously, of coming up with industry-leading data reduction technology is, to today's point, we get a lot of BS hits. Like, yeah, right, I've been burned by these data reduction promises in the past. So-and-so told me I would get 5 to 1 or 6 to 1. I didn't get it, and they said they were sorry and took me out for lunch, but that doesn't really solve my problem. So what Behr came out with about a year ago was this right size guarantee, which is essentially us saying, look, we're so confident in these numbers that we're going to create a legally binding contract between us and you, the customer, that if you don't achieve the level of data reduction that we've told you would based on your workload mix, and we don't need to put any tools in your environment to do this, because again, we have this call home feature that allows us to identify what level of data reduction we're going to get based on the workload, whether it's SQL, VMware, SAP, whatever it happens to be. If you don't achieve that in the first 6 months, then we will give you the capacity to make up for it at no cost to you. Now, the reason that a lot of people say, well, 6 months, does your data reduction get worse after 6 months? If anything, it's only going to get better as you put more workload on. What we find is that most customers pick an initial workload to put on Behr, and they have so much success with it that they want to add other workloads. So the reason that we limit it to 6 months is we don't want to stop you from putting workloads that weren't part of that contract on your flash array. All-inclusive software, Dave talked about this a little bit. So this is an interesting model too. Like sometimes what happens is that you'll buy a storage array and you'll have enough budget for it, and this is great, it's something you want to replicate some of your data. Oh, well, that's capacity-based licensing. How many terabytes do you want to replicate? Well, I can't afford that. Now your solution is missing some pieces, right? With us, all the software that we include is included in the cost. So again, in that subscription that Dave was talking about. On top of that, it's not just features that we have today, but features that are coming out in the future. So we just had our Accelerate conference in June, which is where we had all our customers out, and we announced 25 new software features that are coming out before the end of January. All of those are included in the maintenance. So if you're an existing Pure Storage customer, you're going to get all those features just for the cost of your maintenance, and that software upgrade is going to be done completely non-disruptively by one of our support engineers without you having to take any of the workloads off.
So as an example, one of the things that we've released, something called Active Cluster, which is a metro clustering and synchronous replication technology. If anyone here has ever bought that type of technology in the past, you know this is not a cheap thing to purchase. If you're a Pure customer, you just would have received it. You will receive it as part of your subscription. You just get it. Another thing too on that, quote from Pure will have 3 line items on it: the array, the maintenance, and an install SKU. If anyone here has ever bought any of our competitive products, I've seen the bombs that you guys have had to review. They can be pages long. Sometimes I wonder how you know what you're buying and how the resellers even know what they're selling. It's very, very difficult. With us, 3 line items. That's it.
Any questions on all-inclusive software, right-size guarantee, or everything? No? Okay. Love your storage guarantee. We get a few eye rolls about this one. It's essentially a 30-day money-back guarantee. Again, we get eye rolls because traditional storage is something that you really haven't been able to get up and running and have any idea as to whether or not you think it's the right platform within 30 days, right? And you roll in some of these monolithic storage systems, they're really big and they have to reinforce the data center floor, and sometimes you have to get special power and special racks and all that stuff. By the time you know it, it's been 45 days and this thing's not even up and running yet. Right? With us, we're a simple 3U form factor, rack mount, standard 220 volt power. Wherever you can put a server, we can put a Pure Storage flash array. We talked about our install taking anywhere from 45 minutes to an hour. I've had some customers who are nice enough to have already racked the stack for me, and I'm in and out of there in about 35 minutes. And they actually already have hosts connected, and they've got a workload on them already. So that 30-day money-back guarantee actually means something when you have a platform that is effortless as ours to get up and running.
We consider it to be the new tier 1. And the reason we say that is typically you have very resilient infrastructure as tier 1, stuff that's rock solid, got 6 nines of availability, etc., right? Or you can buy those purpose-built type arrays that can install in an hour and are really down and dirty. We've kind of amalgamated both concepts and created what we consider to be the next tier 1.
The last 2 points here, upgrade flex and capacity consolidation, kind of address the question that you had earlier about the, what do we do with the media or capacity as it grows. So these are both really ways of how the flash array technology enables Pure Storage to protect your investment. So upgrade flex basically allows you to go from a lower end model controller, and we'll talk about the 4 different models that we have, and now the 5th one, to basically scale it up from a performance perspective without throwing away the investment that you've made in your initial storage room. So, one of our smaller models is called the M20. It has a particular performance profile. Let's say over time you've started to outgrow that. What you can do, you can upgrade, so long as you add another 20 terabytes of capacity, because usually you'd be adding more capacity if you need more performance as well, because you're putting more workload on there. We'll give you 100% of the value of what you paid for your investment in those M20 controllers. So your investment in the performance of a flash array never goes away. The second part of this is capacity consolidation. Obviously, over time, media becomes more dense or becomes more performant, or we change types of media. What this allows us to do is take either an entire shelf of our media or even half of one. It's called the capacity pack. We can evacuate that into the remaining free space you have in the array and put in a larger capacity pack with denser, more performant media, completely non-disruptively, and being able to protect your investment. So, for example, if you originally had 20 terabytes of raw capacity, and over time you had some other projects coming on board, and you're like, what? Now I need to scale up to 80 terabytes of capacity. You would only pay for the difference. You would only pay for the additional 60 terabytes. We could remove the lower density, less performant media, give you the higher density, more performant media, and you only pay for the delta.
So to simplify that, how many times have you had to buy or rebuy that same terabyte over and over, right? If you think about it, how many times have you rebought that? Not just the actual media, but also the software that connects to that media. With this, our goal is that you never have to rebuy ever again. The investment you make in Pure on day 1 stays with you forever. That's the goal.
So what does this look like? When we talk about what we've been able to deliver from a subscription innovation, this is an example of what 1 petabyte of usable storage looked like on Pure in 2012. It took up 6 racks, right? Today, with our Flash Array X, we can deliver a petabyte of usable in just a 3U form factor at NVMe speeds, right? So at double the performance of what you get in a Flash Array. And again, this is another situation where we could have protected this customer's investment along the way, right? And then it's the same thing, in those same 5 years, just to give you an example, some speeds and feeds, or a little bit of metrics, if you will, we've been able to grow the max capacity on a flash array 53 times of what our original product ships at, 64 times the density, again, because media is becoming denser and more performant, 16 times less power per terabyte. I don't know if any of you guys are concerned with the amount of power that you either pay for or consume in your data center, but this is a really, really important metric that we're finding these days. 5 times the performance from our original platform, 14 software releases, 4 hardware generations, and absolutely not a single dollar of wasted investment. Right? Through those programs, programs that are underneath our Evergreen umbrella, we're able to 100% protect the investment that we've made in your flash array.
And as a test, how many migrations happened? How many data migrations had to happen during this whole transformation?
Yeah.
0.
Okay, that's the quiz.
There you go.
So this is it, right? We want to talk about what does the product look like. So this is it. Simple 3U form factor chassis. The beauty and the simplicity is that regardless of which flash array you buy, any one of the M series or even the new X series, they're all built on the same chassis, right? And so what you're really getting is different controllers that have a different performance profile, and obviously different types of media or denser media depending on what you want to scale up to. So when you look at the front of this thing, let me see if this thing will work. There we go. So you start up here. These are our MD-RAM modules. Again, in a traditional storage array, you would consider those a cache. Because we're all flash, we do things a little bit different. So that MD-RAM module is actually our staging area. So that's where we do our inline dedupe, our inline compression, and our inline pattern removal. So the 5 different algorithms that they talked about for data reduction. The first three that are in line all happen there. What that allows us to do is obviously increase the performance, because what will happen is that if we're doing deduplication, compression, and pattern removal there, we only have to persist to the media if it's a unique block of data. Otherwise, we just update a metadata pointer in our database, and we don't actually have to flush any I/O to the actual media. Again, because we're an all-flash platform, the fastest way, we don't have to do read ahead or anything like that from a cache perspective, the fastest way to get your hosts their data is directly off the media. So that's why we don't consider this a cache, and we consider it a staging area.
Reads are free, is what we usually say, right?
When you look at the disk in here, so the media, so on the chassis itself, it's broken into 2 capacity packs, each one that has 10 flash modules in there. On the flash array M, which is based on SSDs, each flash module actually has 2 SSDs in there. So when you fully populate this thing, you've actually got 40 pieces of media. Right? So that's what's delivering your performance and your capacity. When you get over to the back, you've got your redundant power supplies. Now, just because of the way that they're lined up, it doesn't mean that each power supply aligns to each controller. They actually redundantly power the backplane in the chassis. So when you pull one of them out, both controllers keep running. And then the controllers, when you look at them, probably look very, very familiar. They're essentially a blade server that's been turned on its side. Right? So you turn it on its side, and this allows us to make them very modular when you're going through your evergreen, whether you're getting your new generation M controllers, right, through your evergreen after your 3-year subscription is renewed, or whether you're scaling up through the Upgrade Flex program. Basically a little handle, pull it out, put the new one in. Completely stateless, so you don't have to worry about reapplying any configuration. It'll read it from the other controller that's in there. Virtualizing the world by names, everything else. You don't have to redo any zoning. You just get the new performance profile with that controller in there.
And this is where a lot of that secret sauce comes in. I hate that secret sauce word. I don't know why I said that. The 6 nines of availability that we talked about comes in this architecture as a result of this architecture. You leverage something that we call a hybrid active-active. So the idea being all front-end writes are active-active, but when we actually progress the data to the media, that's done active-passive. What does that mean? So what? What that means is that we could be throwing hundreds of thousands of IOPS at this box, and if we lose one of those controllers, or you literally pull a controller out, it has 0 degradation on performance whatsoever. None.
So we talked about, we have 4 sizes of the M. So again, the M is the one that's still built on SSDs. We'll get into the X a little bit later. That's on NVMe. But to give you an idea of how we can scale, we can start as small as our model called the M10, which can start as small as 5 terabytes raw. But that would kind of give you 25 terabytes usable, again, depending on the workload. And obviously, you can see the performance is scaling as you go up in numbers. One important thing to note up here is that you might notice that our performance numbers, we are very specific about the fact that it's at a 32K block size. When a lot of our competitors put up what we call our hero numbers, they'll measure that stuff at a 4K block size, right? Which makes them look really, really good. Oh, we can do 8 million IOPS. It's like, okay, well, with no services turned on, so no dedupe, no compression, no replication, and at a 4K block size. That's going to make your numbers look very, very impressive. The reason that we put a 32K block size out there is, again, we have this call home feature. We get all this non-identifiable metadata from our customers, and we can analyze it. And we've identified that our 3,700 plus customers, their average block size is 28K. So we figured, well, why would we publish performance metrics that are at a block size that isn't realistic? Let's put something in there that's real. So these numbers actually mean something. Right?
And all that's taken into account. Remember that performance number that you're looking at here is every single service that Pure offers running all the time. You can't turn off encryption. You can't turn off compression or deduplication. You don't make a decision. This volume is for capacity and this volume is for performance. In fact, regardless of whether you're putting a volume together for VDI, SAP, Oracle, I don't care. The process is name, volume, size. That's it. There's nothing else. Because everything is on all the time. We don't have disk groups. We have a RAID algorithm that was purpose-built for Flash that allows for us to be able to do this. So it's very, very simple to use.
And this is why we call it Pure Subscription Innovation. So admittedly, Dave and I have been here about 1.5 years. We didn't want to use this because it seemed like a pretty serious marketing term. But when you put all this stuff together, right, so software defined, so the fact that, when we developed our Purity operating system, we wanted to make sure that the GUI, the CLI, and the API all had feature parity so that you could consume it whichever way you see fit. Cloud connected with all that Pure One stuff and not having to have infrastructure to manage your infrastructure, but obviously with some very purpose-built hardware that delivers the performance acceleration that we need to keep that sub-millisecond latency, which your business applications are going to demand.
Dan and I had to be sold on the fact that this truly is an innovation, right? This is a subscription innovation. It took us a while to get there. Then we started seeing things. We saw, for instance, we had one customer that their capacity had grown to, was it 86%, 90%, something like that? And they were behind on their purity updates. We applied the purity update to get the code up. As a result, they gained almost 20% of capacity back. So think about that. 20% capacity just by keeping your code up to date. That is without buying any media whatsoever. So that kind of got us sold. That plus when you see what the X is and the fact that it actually is leveraging the same chassis really got us going, okay, this is real.
Yeah, again, part of the joke about we think we're horrible salespeople. Hey, let's give you a 10 to 20% capacity without actually selling you anything. Right? So again, we're trying to do right by you. If there aren't any questions about the hardware or anything, we're going to get into, obviously, I think something that's relevant to this room. We're going to talk about the VMware integration that we have with the Pure Storage Flash Array. So a bit of an eye chart, but really at a high level covering essentially that we have integration with everything under the portfolio, right? Anywhere from having a vCenter plugin all the way down to Site Recovery Manager and being able to integrate with VRealize automation. So we'll get into the details of what each one of these looks like at a high level. So vCenter plugin, again, keep in mind, like we said before, all the software that is included is free, right? So we don't charge for our content pack, for our management pack, for the SRA for SRA, all that stuff is included. Obviously, you have to license your software from VMware, but any of those additions, any of this integration that we're showing you, there's no additional cost from Pure. All the software is included, right? Real simple to deploy. It's something that you can just deploy right from the GUI, from the Flash Array, pushes it to your vCenter. It gives you all this integration so that you can get that level of granularity, the metrics, so whether it's IOPS, latency, everything else, down to the data store level, right? Also provides you all your VAI integration, so that you can offload, storage motion and all that stuff to the array. That's all part of the vSphere plugin, the vCenter plugin. We also have a management pack for VRealize operations, right? So obviously it gives you all the things that you expect to be in there. What flash arrays in there, what volumes, what host groups, and then you can gather statistics around data reduction, how much capacity is used. Again, performance metrics like IOPS, throughput, latency, all the things that would be relevant from a VMware storage performance perspective. It gives you event and object correlation. So again, you pick a particular data store, it'll show you all the events and all that stuff that are correlated to the VMs in that data store, the flash arrays that are backing those data stores, etc. And custom projection and reporting. So obviously, we have quite a bit of that in Pure 1, but if you wanted to do it right from your VRealize operations console, because that's what you're used to working with, then we also have some custom reports to give you, again, metrics on your data stores, performance, capacity, etc. That's all part of the VRealize operations management pack that's included. We also have a content pack for VRealize Log Insight. It gives you 26 customized extracted fields that are specific to Purity syslog messages, meaning that you could run a query based on real specific stuff that's in the Purity operating system, Pure user, volumes, that kind of stuff, right? And
how many people here are using Log Insight?
So you can see here you've got the query that's obviously based on like a keyword like Purity, so that means that you would get the syslog entries from the Purity operating system. And it allows you to create some of these custom dashboards. So this one is, for example, an auditing of who's logged in and logged out and potentially perform storage operations on the Pure Storage Flash Array. Just in case somebody was wondering, hey, who added that data store, who expanded that data store, why did somebody blow away that data store, etc. All that stuff is available in the Log Insight content pack. And then we have the VRealize Orchestrator plugin. So this comes with like 50 plus built-in workflows. It's been designed with VRA in mind, right? So obviously, depending on where you are on your path to automation, most people tend to start with, let's do it for IT first, kind of internally, which is where you would use Orchestrator, knowing that you may eventually want to get to a self-service catalog for X as a service and VRA. All these workflows can very easily be imported.
So think about, I made the comment that all you need to create a volume is a name and a size. That is a heck of a lot easier to automate than, okay, I need to create a disk group, I need this level of RAID, and I need all the things that you typically have to do in a traditional array. Very simple. Of course, we made it that much easier with the VRealize Orchestrator.
Obviously, part of the web client plugin, right? So all your Orchestrator tasks would come in at the bottom, and then again, very easy to import this up into VRealize automation. Obviously we know that you typically wouldn't put storage provisioning as a service out there in your self-service catalog. The idea being is that you would leverage some of this stuff as part of your blueprints for a much larger automation, whether it be self-service VM provisioning or allowing people to take ownership of some of the data stores that they might have so they can expand them as they see fit, obviously based on the parameters that we provide. And this is what it would look like, your Pure Storage as a service catalog. Obviously, you may, for some people, have that, and obviously part of bigger blueprints that you would have for larger portions of automation. Site Recovery Manager, so as we mentioned, we do have an SRA that's compatible with SRM with our asynchronous replication, which again is all included. You don't have to pay any capacity-based licensing for replication. There is very flexible replication topology, so I've got a little slide that kind of covers some of the what's new with VMware stuff. Previously, the many-to-many relationship wasn't supported by our SRA for SRM, it now is. So basically, all the replication topologies that are supported from a Pure Storage flash array are now fully compatible with our SRA for SRM. And virtual volumes. So this is something that's coming up in October, November. We're going to be releasing our support for vVols. I'm not going to bore you guys about what vVols is. I'm sure you've heard quite a bit about it.
Does anyone here not know what vVols are? You good?
I mean, I know I've been hearing about it for long enough. I mean, admittedly, David and I came from VMware.
We both came from VMware, so
I know a little thing or two about it, but what we wanted to highlight is what we're doing a little bit differently. So on the Pure Storage side, basically when you deploy a virtual volume, it just has a different name. It's called a conglomerate volume, right? So really not anything new to learn. We've got some sample handouts at the back, which is essentially highlighting all the command lines that you need to know to be able to administer a Pure Storage flash array. It fits on a double-sided tinted business card. So everything is.
See Raymond's holding one up right there. If you're interested. That's our manual right there.
Yeah, that's it.
And there's our model, Raymond. Thank you.
I guess the big difference is how we're doing our VASA provider. So, obviously every storage vendor is at liberty to implement it as they see fit. Again, because of legacy, we talk about some of our competitors being a retrofit. It's not just a retrofit, meaning that they pulled out spinning disk and put in SSDs. Yeah, that's going to give them a performance boost, but they weren't purpose-built for flash. When we talk about retrofit, it's also with their operating systems, right? If they've got a 20 to 30-year-old operating system, the concept of an API or something like a VASA provider is something that's really hard to kind of wedge in or retrofit into a legacy operating system architecture. Again, because we're more modern, we've been able to deploy our VASA provider redundantly with high availability and completely stateless on both of the controllers in the array. So you won't have to have separate infrastructure to manage your infrastructure. Right? A lot of our competitors are making the VASA provider a separate VM off to the side that you have to manage in your virtual infrastructure. We're trying to do away with that and keep it simple.
Our VAS is running off our control.
That's right. Again, very straightforward. You go to your storage providers, you put in, give it a name, call it whatever you want. Go to the management URL, and basically that's all you need to be able to attach your Pure Storage flash array as a storage provider for controllers. You'll see the two controllers, which one is the standby, which one is the active, and that's it. When you connect, obviously the VASA provider will send back the basic capabilities of the array, and on top of that, provide you the additional replication capabilities of the array so that you can use your policy-based management to provision your storage based on the capabilities that are available for the Pure Storage flash array. And migration to vVols, you guys all know this, real easy, storage remotion. Right? So the real advantage of us being a data-reducing storage array and having that industry-leading data reduction is that if you were going to move from a traditional BMFS data store on a Pure Storage flash array to vVols, as you did that storage remotion, it wouldn't take up any more space because it would identify it as duplicate blocks of data. So you wouldn't have to have all this swing space to be able to move from a traditional VMFS to vVols as long as you did it all in the same storage. And then some other VMware goodness. This background doesn't show very well, but one of the things that we do differently is how we handle round robin from a multipathing perspective. Up until 6.5 update 1, it was something that you had to apply manually to set that queue depth to 1. Most people use a queue depth of 100 or 1,000. That means that you're going to have 1,000 IOs timed out before it decides to use another path. Because we are so performant, we set it to 1 because that's how you're going to maximize the performance of all the multipath connections that you have. That is going to be the default behavior now in 6.5 update 1. Automatic unmap is now in 6.5 with VMFS 6, and support for in-guess unmap for Linux and VMware in 6.5 as well. One important thing to note when we talk about this integration from the VMware perspective, obviously we've highlighted that we integrate with just about everything under the VMware portfolio. But just to show how tightly integrated we are in the what's new in vSphere 6.5 storage, the only other storage vendor that was invited to co-write that paper was Pure Storage. Cody Hosterman, who's our resident VMware expert, worked with Cormac Hogan, who I think most of you might know, and they actually co-wrote that white paper.
Cormac's
Cormac's 6.5.
He's a god, isn't he? Or,
I think
not, he's close.
touched on it briefly. The SRA for SRM now supports the many-to-many replication topology. Important thing up here at the top right is this VMware Validated Design is coming out later this year. This one's really cool because, as you guys know, most of the SEDC 4 or 4.0 VMware Validated Design is the only storage platform that's in there is vSAN. And so our VMware Validated Design is essentially going to be the first VVD that has an actual storage hardware vendor in it. And that's essentially VMware admitting that we're the closest thing to vSAN that's actually a hardware platform. So again, you're truly software defined even though you're not a hardware platform. Again, Cody's written a really nice tool for a VMware snapshot management tool. So, again, we don't necessarily have the full suite of, let's say, Snap Manager products like some of our competitors. But we feel like we don't need to, and this is one way where Cody's, made it a little bit easier to manage your snapshots and actually use them to do restores or to, put them in a separate data store to pull out individual files. It's all totally free, available at Cody's blog site. And then we mentioned this already, default support on VASA 3.0 and vSphere 6.5 is coming out October, so probably next month. All the stuff that we talked about defaults is going to be supported. Real quick, we'll touch on our all-flash converged infrastructure with our friends at Cisco. So, there's obviously a lot of conversation around converged, hyper-converged. Our take on it was, why would we get into, let's say the hyper-converged space and get into servers and that stuff when we could partner with somebody who's already best of breed, right? So basically what you're getting is what we consider to be the first truly stateless stack top to bottom. We take what Cisco does from a UCS perspective and having their server profiles, meaning you can pull out one of your blades, put in a whole new blade, apply that server profile. It's like nothing ever happened. Same thing that we do with the controllers, right? Completely stateless, completely non-disruptive. We've only highlighted, I guess, some of the certifications that we have for VMware, but obviously we have many more other business solutions that are part of our Cisco validated designs on this flash stack converged infrastructure. Again, we talked about our M10 to M70 scaling. The flash stack, again, is a reference architecture, so it's completely modular and you can scale whatever you think you need to. We have some predefined, if you will, reference architectures for a particular size. So if you look at the sample bill of materials for a mini, a small, a medium, a large, what I like about it is that, if you're at least looking for some direction on what do you need to put in to run a certain number of VMs, you've got, 500, 1,000, 2,500, 5,000, right? So again, once you read the full 300 and something pages of the Cisco validated design, it'll tell you exactly what the assumptions are based on, what is the size of each one of those VMs. But it gives you a great starting point to figure out, well, what do I really need to be looking at from an infrastructure perspective to run my 5,000 VM farm. Where are Cisco and Pure winning? Wanted to highlight this. Obviously, vSphere is the biggest workload that we have on our flash stack converged infrastructure. One that really surprised me was Oracle. I thought, for sure, Exadata would be where everybody wanted to run that. We're having a lot of success with flash stack for workloads like Oracle, because people are sick and tired of kind of being tied to, using that infrastructure for just one application. You can't use Exadata for anything else, right? If you decide you want to run VMware on there, well, tough, right? With the flash stack, you can run anything you want. Right? There's nothing stopping you from mixing, vSphere with VDI and carving up some of the hosts for this and some for that, and having all the shared storage in the background. Right? Some flash stack reference customers, the one that I like the most, they like to use sometimes when we order lunch for our customers, is Domino's. So basically, their online ordering system all runs on a flash stack. You can see here, the reason that they're such a happy customer is that during Super Bowl 50, they were rated the #1 on the highest scoring online ordering system during the Super Bowl, which is essentially their, Thanksgiving or Christmas, if you will. They sell a lot of pizzas during the Super Bowl.
It's not the greatest pizza, but that app is freaking cool. To see that Bill's putting it in the oven and then Joe's driving it to your house and see exactly what's going on, I know it's really cool.
And then again, we'll highlight the two Cisco validated designs that we have. One for VMware Horizon 2 and the other one for vSphere 6. Again, the first one is based on an M50, running about 5,000 VMware Horizon 2 users, and the other one is based on an M70, running about 5,000 virtual machines. And again, we can put the links in here because I think all this content's going to be available afterwards. We'll make sure we get the links in there so you guys can review those Cisco validated designs. Any questions about FlashStack before we move on?
Just out of curiosity, how many UCS customers?
There's one.
Two.
Two? All right. All right, so I want to cut it in anybody's time, so we'll go over this real quick. So we talked a little bit about the FlashArray//X. We talked about the M series of family, all built on SSDs. We feel that the rest of the industry is trying to catch up to all flash and still trying to catch up to an all SSD platform. Obviously, to keep our competitive advantage, we have to be 2 or 3 steps ahead of that. And this is why we believe we're the first ones to market with an all NVMe array. So this is essentially, when you look at some of the challenges with SSDs is that, yeah, they're getting more dense, but they're not becoming any more performant. So you're squeezing more VMs into the same media, but you're not giving it any more performance, right? There's some complexity in there. There's a whole bunch of firmware and overhead and stuff inside those SSDs that don't really add any business value. They're there because, the form factor of the hard drive is what, we felt we needed to sandwich SSDs into or flash into to be able to be consumed in a storage array. And it's a black box. There's really no, hey, my performance may be variable, but I don't know why, because once it goes in there, I have no visibility into what's happening inside. So, and there's a lot of capacity in it, right? So what did Behr do? They said, you know what, we've got to be able to do this differently. What if we could take, what you're used to with SAS, being the protocol that connects to your SSD, what if we could get rid of that? What if we could access the flash, the NAND chips that are inside that SSD directly, giving our customers more usable capacity, a more consistent performance profile, and less variability from a performance perspective, right? So that's when we came up with this direct flash module. So you'll notice when you look at this, right? So I talked about how in the M it was actually 2 SSDs sandwiched together. There's no SSD in here, right? This is all NAND chips directly on this direct flash module, right? So again, we're using NVMe as a protocol instead of moving from that serial access, so a single channel pushing data back and forth to the actual media. NVMe gives you 64,000 parallel queues to be able to transfer the data back and forth, right? So massive, massive increase in parallelism. Way less hidden capacity, right? So again, one of the challenges with SSDs is that the way that they wear down, they have to hide a certain amount of capacity because cells start wearing out. With this, we don't have to do that anymore. So there's much less overhead in the media itself, and we'll be able to pass on more usable to you as the customer. And ultra density, but with the ability to deliver more performance, right? There's no point in having an 18.3 terabyte flash module if it's actually not going to give you any more performance because you're just going to try to jam more stuff into the same space. Right?
To put this performance into perspective, we typically today measure latency in milliseconds, right? That's typically what we do. In our standard M series flash array, we're saying we're going to have sub-millisecond latency. That's our goal. Anything above that, we're going to open a ticket if it's sustained proactively. With this, we're not measuring in milliseconds, we're measuring in microseconds. So you're looking at about a half a millisecond of latency leveraging this product.
And again, trying to keep in mind the stuff about simplicity, right? So we're trying to make this simpler. There's less hardware in there. There's less translation. There's fewer layers, right? Fewer things that could go wrong. Again, we're able to deliver faster. So Dave talked about moving from millisecond to microsecond latency measurements, right? So 5 times faster than your typical SSD, and way more efficient, right? Because we're now having the software access the media directly as opposed to going through that translation layer, right? So what do you put this in? Well, you put this in a FlashArray//X. So again, it might look very familiar, right? So the chassis is exactly the same. So any customer that has a current M chassis today, again, they don't have to re-buy anything. That chassis is fully capable of using the X controllers and having NVMe media inside the chassis.
So to put this into perspective, you were talking about the media and whatnot. If you had a bunch of SSD media and you were moving to this, you would get a credit back for the media that you purchased on SSD and apply that to buying NVMe media. So you would lose your investment. And you would be able to transform your existing M array to an X with no downtime and no performance degradation, or like Dan likes to joke, halfway through the migration, you're going to get a significant boost in performance.
Yeah.
Do you get a new sticker that says X?
You get a new sticker.
You will get this new bezel.
Yeah.
Right? So it is a new
That's a good point, though. We should definitely put that at the top of the list.
Yeah,
I
If
agree.
you have like a FlashArray M t-shirt, we'll get you one that says X. Or we'll cross it out.
He's
We'll
got
figure
X
that one out.
shoes.
Yeah, you have FlashArray X shoes. Funny story. So again, to give you perspective, right? So if you have a FlashArray M right now, you have a workload that's running, just under that 1 millisecond of latency, you're gonna have 50% lower latency for that same workload on a FlashArray//X. And you're gonna have 2 times the bandwidth available to you from a performance perspective, and 4 times the performance density. Right? So this is where it's really important. Right? It's not just that SSDs are getting bigger; they also have to get more performant as they get bigger. Otherwise, you're just creating a now bigger problem. Right? That you moved away from spinning disk to resolve that problem. You're just now jamming that same problem into your SSDs. And again, fully upgradable from your M investment, no rebuy. If we have 2 minutes, we'll really quickly talk about FlashBlade. This is our scale-out object platform. Again, for any of you guys getting into analytics workloads, AI, machine learning, Hadoop, that kind of stuff. This is our FlashBlade platform, so it can scale up to an 8 petabyte namespace in these 75 blades. We joke around that it's also available in a, obviously wouldn't lay them out across like that. They come in a 15 blade chassis, so you can fit 8 petabytes usable in just 20 rack units in your data center. Again, combining all that together, you get 75 gigs per second to read, 25 gigs per second write, 8.5 million IOPS, and super simple. One single IP address, one namespace, and evergreen still applies, right? So you have the ability, if you start with a smaller capacity blade, like an 8 terabyte blade, and you move to a 52 terabyte blade, it will protect your investment. You're not rebuying the capacity, you're not rebuying the performance of that blade. Why we built this, traditionally big data was big and slow. And so, a lot of people are building these data lakes and they're not really sure what they're going to use them for. When you finally figure out what you're going to use it for, you're going to realize that if you want to do any kind of analytics on it, that cheap and deep disk that you bought is not going to deliver the performance you need to manipulate that data lake as a whole. And so this is where FlashBlade comes in, is that it gives you the capacity to hold that massive data lake, 8 petabytes, but it also gives you the performance of all flash to be able to manipulate it in place. Otherwise, what you'd have to do is set up a server infrastructure that has some kind of flash media in it, whether it be directly attached to a server or some other storage array, and then you're only taking a subset of that data and manipulating it, which defeats the purpose of building a data lake to begin with. Right? If you're going to only take a subset of it, why did you try to put it all in one big pool to begin with? Right? So this is really taking that from big and slow to big and fast. Just how fast, as an example, 100 times faster to first byte versus AWS S3, and 100 times faster in indexing a million objects versus an existing solution at a leading web scale company. So we're not talking about 2 to 3 times faster, we're talking 10 to 100 times faster than what people are used to from an object store. And again, now with that other product, the subscription innovation makes even more sense, right? So again, software defined, with clear examples of our VMware validated design being the kind of first hardware product that's included in SDDC 4.0. Cloud connected, so all those analytics that we do on our customers' non-identifiable metadata, so that we can identify, what your data reduction levels are going to be without having to be very intrusive and put tools into your environment. And as you've seen, obviously, through the hardware walkthrough, very purpose-built hardware to deliver the accelerated performance that you need for your either business applications or some of your new machine learning or big data analytics initiatives.
So we've thrown a lot at you. We covered off new product, right? New product ideas, and in our Flash Array and FlashBlade, we threw a new business model at you that we've enabled via our Evergreen program. We threw a new support mechanism in front of you with Pure One and our proactive analytics. We threw in the VMware integration and our Cisco relationship. So lots of content in a very short period of time. Thank you for your time, and just curious if anyone has any questions.
If you don't want them now, we sit in the back. I don't want to cut into other people's time.
You just talked about replay or snapshots.
Yeah.
Yeah.
So real quick at a high level, you have snapshots. They are the basis for replication. One thing that's different between our snapshots and let's say our competitors' snapshots is that they are immutable. What that means is that they're not a dependency chain, meaning that if you took a snapshot every hour for 24 hours and you deleted the third snapshot from hour number 3, in a traditional storage array, you would lose the ability to use any restore point prior to that. With us, you still have 23 fully available snapshots as a restore point, cloning point, replication point. Right? There is no dependency chain in our snapshots. Zero overhead, they don't take up any space. They only take up space as the data changes.
The other question, what would I value this type of storage when I can leverage type of convergence with all flash?
So that's a great question. One of the reasons, and again, this is from our perspective, and obviously we work for Pure, we've got the little orange logo on here. Hyperconverged, having worked at VMware, makes a lot of sense for workloads that are very predictable, where you know that your storage and your compute are going to scale linearly. As soon as I saw a hyperconverged vendor come out with storage-only nodes, they basically shot themselves in the foot. If everything scales linearly from a compute storage perspective, why do you need storage-only nodes? You're basically admitting that there are going to be times where your storage and your compute don't scale in parallel, So sometimes you need storage only. This is where there's an advantage in having a converged solution like FlashStack, so that you can, whatever you want, scale up your compute, replace your compute, put higher density compute blades in there. Or if you don't need more compute, you just need more storage, well, then just do the same thing with your storage. You have the flexibility. You're not tied into having to grow those two things in parallel. That's our perspective.
When I was at VMware, I was the vSAN SME for Canada, so we can talk. It's a great product, but it's not always the right fit for everything. So if you want to talk offline, we can go through where it makes sense and where it doesn't make sense.
Yeah, just in respect of other people's time, we'll take other questions later on. We'll be sitting around until noon until this thing wraps up. But thank you guys very much. If you have any other questions, come see us at the back or after the session. Thanks.
Thank you.
Yeah, let's take a 10-minute break. Let's get back up in 10.
Daemon, thanks for letting me come up and speak for a minute. Before Daemon speaks, I just wanted to thank everyone for coming. I also wanted to highlight one person here from Southwestern Ontario, Matt Crape. Matt, you want to stand up, buddy? Thanks.
last week.
So, the reason I'm putting Matt on the spot there is Matt is the Veeam user group for Southwestern Ontario. Is that right?
Yep, that's right. Although we generally seem to meet in Mississauga because
Okay.
it's popular.
Everything
spot.
happens.
Yeah.
So if you want to I thought I'd highlight that, let folks and give you an opportunity to share with folks, you know, a quick
Thanks, Angelo. Yeah.
quick talk about your user group.
Sure. So similar to the way VMUG's a VMware user group, Veeam user group is a user group for Veeam users. I'm a user. Been using the product for a long time. I like to help people. I like to learn more. So I thought, hey, start up a Veeam user group after seeing the success of the VMUG here, and we generally meet 2 to 3 times a year. We just met last week. Some familiar faces here from there. No ETA on the next meeting yet, likely sometime in 2018, whatever year we're in now, so probably January, February, something like that. If anyone wants my contact info, feel free to reach out. I try to post the meeting stuff at swovug.ca, SWOVUG, Southwest Ontario Veeam User Group.ca. That's really about it. Thanks,
Great,
Angelo.
thanks, Matt. And Matt also blogs at, if I have it right, 42u.ca.
That's right. Yeah.
So he's a well-known blogger. Probably seen him. You probably read.
I'm kind of a big deal.
He's kind of a big deal, but guys, he's from Southwestern Ontario. Come on, I mean, we all know everything happens in Toronto, right? So,
Country folk here.
but yeah, so you've probably read his stuff, but now it's great that you'll have an opportunity to meet him here in person. So reach out to don't be shy, ping him. Any Veeam questions, just go right ahead. Don't be shy. So thanks. And one other thing I just wanted to share before Daemon comes back to present. This is your user group. Damon's just giving me this 2 minutes to speak, so I'm just gonna. This is your user group, so be sure to give your feedback on the topics that you want to discuss. I mean, I can see us doing hopefully see us doing like working group sessions in the future with technical resources from different companies that you might be interested. So it's more than just we have to treat this more than just faces in the seats, if you know what I mean. This is a great opportunity to get to know everyone, especially in the Toronto area, and some of those that have come from outside of Toronto. It's a way of all of us connecting and building our network, and hopefully we can stay connected throughout the year and meet at VMworld, and more importantly, meet here at our UserCon. So thanks, Daemon. I just wanted to share that. So thanks.
Awesome. Okay, so I'm going to provide a topic over here that's a little bit different. I'm not going to be talking about a specific technology. I'm going to be talking more about a strategy that you can use in your infrastructure using various tools. And a lot of it's fairly theoretical, But at the end of the presentation, I'll show you some actual tools that you can use to implement this. So first off, I want to talk a little bit about the evolution of computing. And one thing that has happened over the course of the last few decades is that technology has become a lot more complex. You have phones that have more computing power in them than the original computers that were used to launch rockets over to the moon. You have a lot more power in your hand than you ever had in the course of history. The amount of complexity in technology seems to be advancing and advancing in a logarithmic rate. Now, a lot of that complexity is hidden. Now, the technology such as the iPhones, the smartphones of the world, you have an easy access to the operations of them. It's very easy to learn how to use them, but you don't necessarily need to know all of the little bits of technology in order to use them. You don't need to know all the different chips and components and the traces in order to have an iPhone or a smartphone. You simply just use it, and when something breaks, there's a good chance that you won't be able to fix it unless you really dig down and you have a lot of time in your hands, but usually it's not cost effective in order to do that. And the more complex things are, the stranger ways that things will break. When something breaks in a way that is not expected, especially in circuitry, there's actually a term for it called a sneaker circuit. And it may change the function of a device into a way that is unexpected. The more complex technology gets, the more these things happen, and the more difficult it is to predict how something will actually fail. So the operations of the technology is only surface deep. You don't need to delve into the actual engineering of something in order to use it. But is that really a bad thing? We are able to use very, very complex things as if they're nothing. I have a 2-year-old daughter, and I gave her my iPad, and within seconds she knew how to go into the settings and start touching different things, and she can open up videos, and it's all very intuitive. So the ownership of the technology has shifted. Everything that you get nowadays is more of a service. It's something that's easily accessible. But the actual ownership of the technology usually goes over to the manufacturer, the vendor, the people that make the technology. Everything is a service nowadays, whether it's your washing machine or smart toaster or everything else like that. You simply use it as a user. You don't need to know how it works. But sometimes complexity is added as a feature, and it may just be poor design. You may get a multi-function tool that can do a million things, but you only really need to do one. And that is just poor design. You wouldn't necessarily get like a Swiss Army knife in order to build a skyscraper, but if you got a specific tool in order to do a specific job, that may make more sense. So why would this really matter if it's a model that works? If the whole industry is moving over to a service-based model, what's the problem with that? The problems really occur when you don't get the service that's required for the specific technology that you're using. So if you have a certain SLA that's associated with the technology, and you're not getting that, then you're not getting the use of that technology that you really want to do. So it becomes a dead weight and a hindrance to the business. If something breaks and you can't fix it, then it's completely useless. It's not something that you can really rely on. So in this sort of model, where everything moves to a service-centric model, you're outsourcing the risk to your company to a service provider. they are the ones that are responsible for ensuring that your technology is actually working properly. And if you don't get the proper SLAs from them, then you're putting your business at risk. So I'll give you an example. Let's say you have a modern washing machine that has a certain amount of software in it and it's working properly, then all of a sudden it doesn't go through the spin cycle anymore, and there's water stuck in there and you can't repair it. You go through the standard tests, but it says that there's an error in the actual software, there's a bug in the code of the machine. It's not something that's easily repairable because you don't have access to that. This is happening a lot more with not just washing machines, but also with other things. Like if you look at a big scandal that came out recently with John Deere tractors, there is a whole community of people that are hacking the firmware just so that they can repair their tractor on their own, so that they don't need to bring the tractors into the John Deere repair shops and pay the extra fees associated with that and the higher service costs. So if something is not physically wrong with it, and the vendor is not providing the SLA in order to repair it properly, then it essentially becomes useless. And the reason that I use a washing machine for this example is because I'm actually going through this process right now. I have a broken washing machine at home, and it's driving me nuts.
So that's numbers.
What's that?
I'm teasing you.
All right,
You said you have a 2-year-old at home, right?
I do, yes.
All right.
So if we look at an example on the technology side, let's say you have an old fiber channel SAN, and it's been working well for a number of years, except that it's out of support. And the SAN has a failure because you're adding some new hardware over to the environment, and you don't necessarily have the right compatibility, so it's creating an issue. You go over to the vendor to see what they would be able to do to help you with this issue, but they basically say that your SAN is out of support, there's nothing you can do, you need to buy a new SAN, you need to upgrade your whole storage infrastructure, but you don't have the money for that. So in this sort of scenario, which is very common, what would you do? And a way that you can approach this is you can look at your infrastructure as a set of states, and the desired state that it's in and the different states that it can actually be in. So if you look at all the different components in your environment, whether they're services, applications, devices, endpoints, everything that you would have in your CMDB, and assign states to them. Are they operational or are they not operational? This is a very simple way of looking at it. Those aren't the only states. You can also have partially operational, and you can have things that fail in a certain way. But for simplicity, let's just look at a binary state, either operational or not operational. After you look at all of the different states of the inventory objects within your infrastructure, then you can take those binary digits and you can turn it into a decimal so that you can actually create a number or a numeric state for that. If you have locked, it's easier to create hexadecimal numbers, so you have a specific state for that. But I'll show you how that actually looks in a second. Some things that you'll find is that there's no silos in the infrastructure itself. There's dependencies. Certain things require other things to work. If something breaks, it's not going to break in isolation. It's going to break and affect other things that are associated with that. So the total number of possible states gets reduced to the total number of probable states. If something is going to fail, it's going to affect A, B, and C. So you will reduce all of the possible states over to the probable ones, which would be this fails and affects this, this, and this. So by understanding the dependencies between the different objects in your infrastructure, you can build out a cascading map of failures to see what affects what and how many failures you can actually tolerate. So this is an example of a failure dependency map. So let's say that we have device 1 over here. Device 1 fails, and that affects application 1, which is associated with service 1 and application 2. So because of the failure of device 1, it creates the failures with all those other components. However, device 2, application 4, application 3, and service 2 are not affected by that whatsoever. But by understanding the dependency between those, you would understand the probable states if a certain failure occurs. So the state change map for the components would look something like this. You go from a state of 1, which would be operational for all of the different components, and then that may be the ideal state of your environment, over to a different state where you have certain devices and applications that are not functioning properly. And based on that a binary number, you can create a certain state ID for that. Now let's say that we have another failure in the environment where service 2 fails, and that's associated with application 4. So the way that would look in this instance is you have the initial good state, you have the first failure which goes over to this, and then you have the second failure, and then that ends up to this state over there. So each step of the way, you go through a state change. It changes the state ID of your infrastructure. Now, when you're looking at the dependencies that are associated with each one of these objects within the infrastructure, it's important to understand how critical is it, or each one of these components to your business itself. The easiest way to approach this is to look at the applications that are in your environment and what were to happen if those applications were to go down or not be available to the business. If you approach the business owners and you say, hey, if this application goes down, how is that going to affect the business? Then they can start providing some information for you, and then you can populate this. Since you understand the dependencies of what would actually be associated with those applications, then you can assign a criticality to each one of the components in your infrastructure. Now that you understand the criticality of components and the interdependencies, then you can determine how much effort and money you want to associate to ensure that a failure doesn't happen in this environment. Now, an interesting thing that occurs after a period of time when you're looking at state changes is that you start recognizing patterns. If this group of services or these objects fail, that may have a cascading effect on this, and then this, and then this, and it will have a certain flow to it. If you know what an initial failure is and what has happened in the past, then you can determine what may fail in the future and what you need to be aware of. So if you're in the process of certain parts of your environment failing, you know what to expect, and you may be able to prevent that because you understand that the whole flow of that failure. So getting back over to the old SAN. Some things that you can do in order to ensure that you're making the best use of that SAN and that you're not putting things at risk is you want to look at what applications and services are associated with that SAN. And what would the recovery process look like in a failure or a situation? If you have a catastrophic failure of the SAN, do you have a DR plan for that? Do you have a recovery process for that? And how does that associate with your recovery point objectives and recovery time objectives for the applications? And that starts going down the DR path, which is important to get the applications back up. But what isn't always accounted for is what happens to that hardware that you've basically abandoned and put to the side. It's no longer in support. You're not able to get it repaired, but are you able to get expertise in there in order to get to a state in which you can use? And if you get it to a state in which you can use, would you want to risk putting workloads on that? How can you really make use of that hardware that has been repaired or put back into a working state? Is it something that you put in your dev and test environment, or would you just take the pieces and then sell that off over to a recycler? So these are the sort of things that you need to plan up before a failure actually happens with things like this, with out of support equipment. If you determine that you want to ensure that the things come back up and that you have proper support for these sort of pieces of hardware, then it may be a good idea to go out and seek the expertise that can help you to bring it back up and to support it proactively before you actually have a failure. But then you have to start looking at the cost. What is that going to cost? Is it something that you can justify, or should you just remove all that hassle and all that headache and then just end of life that hardware and decommission it from your environment? And that kind of goes into a strategy of what is the life cycle for your hardware? Is it something that is based on what the vendors provide? Is it like a 3-year life cycle? Is it a 5-year life cycle? Or do you actually want to make the most out of your hardware and run it right over to the end of life where you have a complete failure? If you do so, you don't necessarily want to run active workflows on that, but you may be able to repurpose it and use it in some way that if you do have a failure on it, you have some redundancy or you have some application level clustering in order to compensate for that failure. So the key thing is to get the most out of your infrastructure, understand what are the dependencies associated with everything, what is the risk associated with running things that may be out of support or out of date, so you can really get an understanding of the dynamics of the infrastructure and not just succumb to the 3 or 5 year life cycle. And you can actually end up saving a lot of money that way by understanding the network, the infrastructure to this state. So different tools that you can use in order to do this sort of thing are machine learning and behavior analytics software. And that's a bit of a broad thing, it's not specific. But the reason for that is because you're going to be seeing a lot more of this type of software coming out in the near future. There's many companies that are applying machine learning and analytics to the behavior of infrastructure so that you can understand these sort of things. Oftentimes it'll be around how users are behaving in the environment, or what is the predicted outcome of a certain performance trend. But you're going to see many different types of behavior analytics in infrastructure environments like this. So it's good to be aware of the different companies that are providing these sort of things right now and start working with tools, because they're going to be a lot more apparent and pervasive in the coming years. Some of the tools that you can use are workflow analytics software that integrate with ticketing systems. So in order to understand what is the process in order to do recovery on an object that may have failed, or what you need to do in order to mitigate risk of a certain failure, you have to understand the human element to that. What is required from the people in the infrastructure? Do they have the skills? Do they have the knowledge? Do they have the tools that they need in order to repair it? Have we gone through a dry run to ensure that they're able to go through that process? Most organizations have some sort of standard DR policy. If this fails, then this will happen. But that doesn't include all of the unknowns, the things that you need to be aware of that are the equivalent of the sneak circuits. As complexity increases, you're going to have more odd failures that don't fit the mold of a regular DR plan. So these are the things that you need to understand. What is it going to take for the people within the organization to be able to respond and react to those? Mind mapping tools are excellent for this as well. In order to create things like failure dependency maps and understanding what's associated with what. Mind mapping tools are fantastic. Sometimes it's even easy to just do that through pen and paper, and then you take a snapshot of it with your phone and then upload it over to Evernote or OneNote or some other tools like that. As long as you have some means to start the process of creating these dependency maps, then you'll be better off than if you didn't do it at all. Some utilities that you can use within the vSphere environment and the VMware ecosystem in order to do this are using vSphere Infrastructure Navigator, vRealize Network Insight. App Defense actually does a really good job of dependency mapping as well. And Log Insight will also help you with that as well. So by understanding the way that these different tools work, you can put them together to get some insight on the interdependencies and the reliance on different components and objects within the infrastructure. And lastly, third-party infrastructure analytics software. VMware's not the only vendor that's providing tools like this. There are many other organizations that are providing monitoring software that provide this sort of insight. So I'm not going to go into the list of these different companies because they're not here, so I'm not going to do advertising. But just suffice to say that there are a number of companies that are doing this, and it's good to be aware of the different ones. So that's all I have for that talk. Bit of a short one, sweet one, but hopefully it's providing you with some insight on different strategies that you can use to make your infrastructure more resilient and the things that you need to consider when you're designing resiliency within your environment. So now would be time for Tanium.
Hi. Or a break. We need a break.
They just have a break.
Just have a break. No breaks.
No breaks.
I'll leave this.
Do you want the laptop and switch it off?
No, I'll connect my own.
I know this. You want
I
VGA
can
or
do
something?
that. Oh, HDMI is great. I got that too. Okay. That's it. Yeah, thank you. Or your power.
Yeah, go for it. That's actually like.
While we're getting ready, I'm not sure if did you mention your book?
No, I didn't.
While we're getting ready, just want to take a quick second. Daemon actually recently published a book called, let me see if I get this right, Designing Risk in IT Infrastructure, right? And you can if you want to check it out, you can find it at designingrisk.com, as well as we actually recorded a podcast yesterday. Was it yesterday? It was yesterday. Yeah. No, it was Monday.
Was it?
Sorry, it was Sunday. Man, the days just kind of blend. We recorded it Sunday, published it Monday. So if you're interested, check out if you're a podcast listener, check out the Nutanix Community Podcast. He talks about the writing process, how we got started, waking up 3 a.m. in the morning, putting a chapter together, writing on the train, in the quiet zone, putting his chapters together. So something to check out, Designing Risk in IT Infrastructure at designingrisk.com. So I just wanted to put that plug in because I know he wouldn't plug his own book. So thanks, guys. Thank you.
Cheers. Hi guys, I'm Darren Hamilton with Tanium, technical account manager. So technical questions are more than welcome here. I run our technical account manager team for the Northeast US and Canada. I'm based here in Toronto, actually out in Stouffville. So I'm not here to bring an American flavor to anything we're going to talk about here today. Before I start, who here has seen Tanium? Seen Tanium? Okay. Who here hasn't heard of Tanium? Okay, all right. For those who have seen or heard of Tanium, who here thinks it's a security tool? No, okay.
ops tool? Okay. It's a bit of both. This is my last slide. So I'm gonna, no offense to anybody who's shown slides before this, but I'm gonna show you guys a live demo of Tanium. And I'll encourage you guys to ask me any questions that you have. I'm used to it, and no question is off limits, and the more technical, the better. I've been with Tanium for 3 years. I was 5 years with McAfee before that. Hopefully that doesn't taint anybody. And I was 8 years with British Telecom before that. So I've got a pretty weird, varied background in IT. What I'll do is I'll show you how this thing works and why it was built. Okay, is that fair?
Yep.
Give me about 25 minutes, and more questions will extend us, but I think I've got about 45. Is that good for a time check, give or take? Sorry? Okay, cool. All right, so let's dive in. Just in terms of customers, what we do is first of all, let me explain the title, Bringing Unsexy Back. This is not my standard title, I just came up with this off the cuff. What we do is we help our customers manage their compute resources, their endpoints, whether they're in the data center or whether they're on an end user's laptop or desktop machines. What do I mean by manage? Is make sure that those devices are secure, healthy, operating correctly. It's a pretty broad definition. I'm going to show you guys a standardized demo of how we present Tanium to customers, but I will show you under the hood a little bit, make it a little bit more technical than normal. I think you guys can probably handle it. And I'll show you that what we're focused here on is the basics. This is not single pane of glass. It's not AI driven. It's not big data. It's not machine learning. It's not any buzzwords. It's back to basics, making sure your machines are operating as you expect them to operate. Okay. So here's the interface. We start with a Google-like search capability where I'm going to type in a question that I'm going to ask of the machines that I manage. So I'm going to start with something pretty basic. What are the computer names and operating systems and IP addresses in my network? So we built a natural language parser. That's the first thing. So you really don't need to understand a query language in order to use Tanium. So I have C-level executives with console access to this tool in my customer base. And everybody goes, whoa, my CISO, my CIO is going to have access to a tool? That's scary because they're going to break stuff, right? We built a technology that allows you to do what we're going to do without breaking stuff. And I'll get into detail about that. So, short learning curve. When I click on the first item here, this is where the magic happens. What we built, and hopefully the network holds for me here, what we've built is the ability to collect arbitrary data from the operating systems that you manage in real time. So what I'm showing here is always live data. And the capability that we developed was designed for large scale first. We took the opposite approach to what startups do in the security space if we're to be pigeonholed as a security company. We didn't build a cool technology and then figure out through disrupting existing incumbents how we scale that up market. We went to the top tier of our former customer base. Founders of Tanium built out BigFix. So whoever remembers that name from now the IBM, BigFix, Tivoli portfolio, whatever they're calling it these days, they decided they were going to take some of the customers that we had worked with in the past and solve some of the problems that patching tools couldn't, especially as it relates to security use cases, but outside of that as well. So we built a technology that scales up naturally to hundreds of thousands of endpoints. and allows you to collect data from the operating systems in real time from those endpoints. And the endpoints being, just skipping ahead a little bit, and I'll talk about architecture later, Windows, Linux, AIX, Solaris, and Mac. So the compute resources that you rely on, not mobile, not network, not those devices, the ones that you have a hard time controlling, the ones that move around a lot, the ones that are constantly in flux. Okay? So what we've done here is touched about 1,100 machines. This is a virtualized lab environment. It's running a mix of operating systems. You just see Windows at the top here. And we're collecting some pretty basic data. But I need to stress that this is real-time access to this data. There's no database underneath this. There's no query where we're going to a static data set that exists somewhere in a centralized location. This is live from the endpoints every time I do it. And again, the technology that we built allows you to collect this data at scale in real time without breaking stuff. Breaking the network. I built some of the biggest, most complex networks on the planet. Built the embassy network for DFA. And this kind of technology works at that kind of scale, no matter how complex the environment is. And it does it in a very simple way that I'll get to later. We won't focus on architecture now, we'll focus on use cases first. Okay? So let's do something more interesting. Let's get all the installed applications from all the machines. So the use case could be anything you can think of that's an installed application that you're trying to find. Maybe you're trying to find where you've got a risky application, like Dropbox or something that you don't like. Maybe it's malicious. I'll get to a malicious application use case. Maybe it's a license audit. So Microsoft comes to you and says, hey, where's your SQL licenses? Well, we collect all of the applications and versions from all of the machines, and we enumerate them and give you that entire data set. So you don't have to go hunting. You don't have to look for a specific thing. You ask for all the things. You cast a wide net, and then you look through those results. Maybe you're going to send these results to a data lake or to a SIM, or maybe you're going to do what I'm going to do in real time, and you're just going to maybe apply a filter. Let's just look at the Windows machines. And when I apply a group filter, you'll see the question change in a sec as I deal with, and this is a live demo, so all the standard demo caveats come along with that. I'm going to blame the network a lot. So I've asked a filter question. That's what I've highlighted here. Only the machines that are Windows machines should return to me a response. But this is live again. So I've asked a new question of the environment. I haven't gone back to that first data set and said, give me just the Windows machines. I went back out to the environment again. I don't trust that first data set. It's not live. Let's go get it again from all the Windows machines. Give me all the installed applications. Now let's look in the results for something interesting like SQL Server. And here you go. I've got 3 machines that have SQL Server 2012 installed. So we can just keep iterating down this process of collecting whatever live data you need to answer whatever question it is that you have top of mind right now. So I could do a drill down. Let's do that. Let's get the computer name and CPU details. So the idea here is to find out how many cores I've got SQL Server running on. So you might think of us as a security tool because we're helping to find the things that shouldn't be in your environment and close holes. But this is not a security use case. This is helping your CIO or your CISO or your VP of applications or whoever find where you've got SQL installed.
Compliance.
It can be used as a compliance tool, yes. But I'll get to where we're beyond that too. Yeah. But, as you would work with a standard compliance tool, like Foundstone or something like I've worked with, Wallace, you usually have to be very specific. I'm going to find SQL Server. How do I define that? How do I write a script that says, how do I find SQL Server? We'll just take a different approach. Let's ask for all the applications. Okay? So I've got this many cores running SQL Server right now. So I can find all the dev machines that have SQL Server installed based on a gold image that was spun up that's got SQL Server embedded, or they've got access to SQL Server installers and they're installing it and impacting my license count. And I can go to Microsoft and say, this is the definitive list of machines that are running SQL Server. You can't charge me an overage for this. This is an exact list. It's real-time data. Make sense? All right, so that's an ops use case. Let's focus a little bit more on security. So we play this one out as a simple illustration of how real-time data matters. Installed applications you could get from SCCM or Altiris or BigFix, or maybe from your vulnerability assessment tools and processes. You might have staler data than you would like. This is a case where real-time matters. And again, I'm not looking for something specific. I'm looking for everything that's running in my environment right now. I can't even describe the use cases that I'm displaying here before we're done collecting the data at scale. I've seen this question run on 380,000 live machines and return a 99% complete data set within 60 seconds. So that's every process that's currently running across 380,000 machines and a hash of the binary that wants that process. So what could you do with this data? Find something bad, right? So we go to an old US cert notification, because I've got a plant, because it's a demo environment, so I've got something interesting to find, right? This is backup point of sale malware. Retailers love to hate this one. It's just one example of many. And I'm going to find the file hash down here at the bottom. Here we go. This is the hash of a file that is malicious. That would be really tough to find once you have Tanium. So I'm putting the hash in here as a search criteria. And lo and behold, it's a demo, so of course I've got something running this malicious process. But what's important here is that I've now got a machine that's running a Java, what looks like a Java process. That's actually point of sale malware. We're going to come back to this. Okay. But this is running right now in my environment, live. There's a process executing called java.w. The file that launched it has this hash. So what do you want to do with this information? Well, you can do a drill down and you can say, okay, who's logged into that machine, what computer name, what IP address, where do I find it, who do I notify, let's trigger a ticket. All that stuff we could facilitate and automate. Or let's do a deploy action. So the marketing guys at Tanium love, I hate the marketing guys, love the marketing guys. They say ask, no act. So we're going to ask for a data set. We're going to know something about the environment as a result of something we found in there, and now we're going to act on it. And we're going to do all that in real time. So here I'm going to play whack-a-mole by killing the process, and I'm going to reissue that every 10 minutes. So this is my first step. Yeah, I got to triage this. I got to figure out how many machines are in scope, how many machines have been compromised. But in the meantime, let's at least put a stop to the damage. Let's kill the process every 10 minutes. We're going to ask every single machine, if you're running this process, kill it. If you're running this process, kill it. Okay, that's one step. Let's go a little further, because this is what one of my customers co-developed with us. Let's quarantine the asset. So I can put a IPsec PF policy down on those endpoints at will whenever they're running this malicious code. So I can essentially knock that machine out of commission from the perspective of its ability to access anything else in my environment, no lateral movement, right? But I still have access to it because I can define what it can talk to. I can say, yeah, it can still talk to DHCP, DNS, my Tanium servers, maybe my AV console, maybe I've got some specific processes and tooling, maybe my MACV console, maybe it's my semantic console, Trend cares. It's arbitrary, you can define it. But we're going to take that machine out of commission while we continue investigation of this issue. Okay? Stem the bleed, and then move on. Find out how it got there. Make sense? We good? Okay. So, stop me if you have any questions.
What's the notification message? Or is that
Whatever you want.
But where does it go?
Pops up to the user. Yeah. So we're just going to pop up to the end user. You're infected, call the help desk. We've already raised a ticket in service now for you. We want that. We want to automate that use case out of with you. Yeah, go ahead.
My first question, do you use like agent technology, agent list? And second question, because you're doing real-time scanning, you're supposed to have very high level of privileges to find all this information.
Yeah, really good question. So the technology is agent-based. It has to be. That's the one thing. Otherwise, your network is not going to be able to do this. It's not going to be able to support this. I know that from personal experience. And the very high level of privilege, yeah, I'll get to that. But in short, we run as an agent, as a local system, or as root, but not at the kernel. So we're really simple to deploy. We have a DoD customer that was deploying at a peak under an incident, 10,000 agents per hour, and we weren't disrupting their operations in the process. It was 5 years of McAfee. Who would deploy 10,000 agents of HIPS in an hour? Right? Or any AV for that matter. What's going to happen? You're going to get a phone call. You're going to update your LinkedIn profile. RGA, right? Or RGE, revenue generating event. So we're light touch on the infrastructure, but we are deep on those machines because we're getting pretty in-depth data from them. We can get data from the kernel, but I'll explain to that. I'll explain that later. Question. All right. So what if you don't know what question you want to ask? How are we doing on time?
Last time.
Good. Okay. So what if you don't know what question to ask? I get that a lot. What do I type in here? So what we built out are question.
Yeah.
No. What's that? No. Good. Okay. We built out all these dashboards. So the dashboards are just questions that have been saved and organized so that our customers can dive into Tanium and use it to their advantage. Yeah.
So, can these questions be told to be asked on a regular basis?
Have to be, yes.
Can you
Yes.
repeat the question?
Yeah, I'll repeat the question. So, if I can read into your question, I'm asking that question right now. What if a machine is offline? So what do I need to do? I need to schedule that question to be asked on a recurring basis. Because as machines come and go, virtual machines maybe, you'll see Amazon's logo on our website. You can imagine what they're doing with Tanium at scale. They're managing probably virtual machines. I won't go into any more depth than that under NDA. But yeah, the environment's going to be fluid. So we'll take any of these questions and we'll ask them every 4 hours, every hour, every 10 minutes, or once a day. Depends on the use case. Yeah. Yeah, question?
What is the average load of the agent on Unix or Windows machines?
Can I hold that question? Because I'll show you how we operate under the hood, and it'll be pretty self-explanatory. I'll still walk you through it. Okay. It has to be light, because we're going to do this in business hours with no concept of scheduling. But customers that are asking dozens of questions per minute, we're capable of asking dozens of questions per second without being impactful. You still have to execute some here, but I will show you exactly how we operate. Let me just play out one more use case here in the dashboards just to illustrate some of the common use cases. Actually, I'll pick on a couple here. One that I think is back to that SQL use case that I don't always show. Application usage by month. I said we're usually thought of as a security tool. But what if you could have an application rationalization program pay for Tanium? Meaning, if I can use Tanium to take applications out of my environment that aren't being used, there's hard ROI, there's hard money to be saved there, that in many cases can pay for Tanium, regardless of what you use Tanium for outside of that. So a lot of my customers will use this content, which looks over time at application usage, not just what's installed right now, like I showed at first, but what's being used over time, and anything that's not being used, like Java versions. This is kind of back to security hygiene, making sure that you don't have things that are risky running in your environment. It also can be a cost strategy. We're going to remove some applications from the environment, like Java 6, update 27. Well, maybe this is an EMC application. I was talking to somebody about this yesterday. There's a specific UI that requires an old version of Java. So if you've got an application owner that says, no, we can't get rid of that version of Java, we need it for these applications, you can help them identify which users are actually using that application. And anything that's outside of that scope of risk, decommission all those old versions of Java. Get that risk out of your environment. You have the visibility to do that. Yeah, question?
Do you have the ability to create kind of like a machine profile of expected apps that you would have on your workstations?
Yeah.
To be able to flag people quickly when they've installed things?
Wow, that's like you've seen this before. Because that's literally the next thing I show.
All right, that's cool.
Well, before you go to that next thing that you
Yeah.
said before that you're not keeping stuff in a database. So are the operating systems telling you
Yes.
what applications have been used and when was the last time it was used?
So with that one, we're doing a little bit of trickery. What we're doing is we're asking every 5 minutes, what's every machine running? And each machine will record, I'm running Java 7 update 76 locally.
Okay.
And then we're asking for that data rolling when we ask the question.
Okay.
We're keeping that data local.
Okay.
That's fundamentally how we address a lot of those historical use cases, is we're going to keep a data store locally on the machine and query that in real time. Some very specific cases I'll actually get to. Back to the question in the back, which was an excellent question.
All right.
Let's do data leakage. What's data leakage mean in security vendor vernacular? It's social security numbers, social insurance numbers. It's stuff in the documents that are being sent. We look at it from the operating system's perspective, which means what applications didn't I authorize to run? So exactly your question. And what external IPs and ports are they communicating on? So this is not just what's bad in the environment in terms of execution, but what's connecting outbound to leak. And you'll see here, I've got MIRC running in this environment, connecting out on a random high order port. That's not terrible, but not wanted. This is probably terrible. SVC host connecting outbound on what looks like HTTPS or SSL 443. Holy crap. Seriously, run, and or do this. Okay, let's deploy action. And anytime we see SVC host make an outbound connection, let's automate a deploy action that quarantines that machine, because that ain't right. That's gonna hurt. Okay? Should not be doing that. So we're not just saying SVC host can't run, we're saying SVC host can't make outbound connections here. Right. So you do have to enumerate the list of applications, but we did that in the first use case, right? You can simply push that as a list, a whitelist, a data file, literally, down to every machine and keep that updated through an automated process, what should be allowed in the environment. Yeah.
The question here. So how do you maintain that list? With new versions and
Yep.
updates?
How my customers use this is they will either scan a gold image for what should be there, and or depending on the use case, they will run a periodic scan. I run it daily so that any new application that launches or gets installed, depending on the use case, you might want installed or you might want running, gets alerted or dumped out to a file automatically and enumerated.
What about versions? Like for example, Java, as we saw before.
Yeah.
So
What we're looking at here is just the process. Just what process is executed, and is that allowed?
yes, but is it hash based or
This is just process name based.
process
What-
name?
Well, we could do this based on a hash. You can customize it. So if you wanted to do it with a hash, sure.
Yes, but then you get the versioning problem, right? Because every version of the executable might have to.
Yep. So you're going to build some automation with our help into that process. Yeah. We have mechanisms built into Tanium to push out data sets to other sources. You could write to a flat file or push to a SIM or push to a data lake and then have execution fed back in through an API. It's a good use case. It's not one I can talk through in detail, but yeah, heard it before. Good one. Yeah. Okay, so let's just carry on a couple more capabilities within Tanium. What we've done to, frankly, to monetize Tanium is we build modules on top of this capability. So our customers come to us and they say, this sounds great, can you replace tool X on the endpoint, whatever it is. So we say, yeah, we can build out an overlay UI for that use case. So discover. We're very literal in our naming conventions. There's no creativity here. Discover discovers assets. No surprise. These are all the assets in my environment. These are the unmanaged ones. These are the ones that you want to deal with. You can see some data points, host name, maybe device type. What we're doing here is we're using some really simple mechanisms that we have at our disposal on each Tanium agent to look at its ARP cache, what can it connect to on its local subnet, maybe do a light Nmap OS fingerprint of some of the devices that it finds, and not outside the scope of its local subnet, so you don't have to put in a whole bunch of network controls. The firewall guys aren't going to hate you. And we're going to control these assets. So we're going to tag them. We're going to ignore them. We're going to block them. We're going to deploy Tanium clients to them. We're going to bring them under management. Okay? So what our customers do to deploy Tanium, they put our agents out there using whatever tooling they have. Then they use this to find what got missed. So we get a complete coverage over time of their environment. You ask an average CIO how many assets do they manage? Guess what the over-under is? It's at least 20%. At least. So a typical Wall Street bank will say, I think I have 400,000 endpoints. Maybe 350, maybe 450 on any given day. Not sure. Yeah, question?
You deal with IoT devices.
No. Not yet. Wish we could. But the platforms don't support what we do yet. And the architecture that we've built doesn't quite support IoT yet. It's something that we have on our long-term roadmap. But, you know,
I think you could help the previous gentleman with the issue with his washer, He would have proactive management and remediating his deficiency in laundry.
Yeah.
I'm just saying there, sorry.
No worries. I've heard this kind of, well, without the washing machine, but not far off use case before. We do help enumerate those assets and bucketize them, put them into a known scope, which is often part of the challenge. But actually controlling them, managing them is...
Finding out what segment they're in and then isolating them off.
Yeah, yeah.
Not open endpoints.
Yeah, so anything I'm doing here, I'll use critical infrastructure or PCI environments as a good example. Anything new that pops up, we can alert on that, send that to the appropriate organization to deal with it. That's a typical use case there.
You're going to talk about architecture a bit later.
Yeah.
Because I'm kind of curious to know about security around all of this. As a hacker, I would love to get into these agents.
Of course you will. Yeah. Yeah, so I'll fast forward, give you a real short cop-out high-level answer, which is FIPS certified, widely deployed in the DoD. There's public statements about that in the US. So we pass through all those gates, but I'll do some due diligence and explain to you how.
Or are you relying on the customer's security to make sure?
I will do it some justice, and then it behooves discussing for sure. So, with great power comes great responsibility. Spider-Man analogy applies to everything here. All right, so a couple more things that I just want to touch on, then we'll talk about architecture. I want to illustrate through a security use case because I talked about that running processes, let's find something bad and deal with it. So the first thing that happened when we showed that to customers about 3.5-ish years ago is they said, well, we're getting all these threat intel feeds and it contains hashes and IPs and all kinds of stuff, registry keys, bad things. Can you help us deal with that? So we said, yes, we built a tool that will consume IOCs and convert them into Tanium questions. So here's my back off last malware that I already showed. That Java process actually lives in here in the list. Well, it comes in looking like this, raw XML, and we make it readable and turn it into Tanium questions, and then we ask it in real time. You can schedule it. So we can take whatever feed that you have, maybe you've got a taxi server that supports IOC curation, where you've got Palo Alto Wildfire or some other source of IOCs. We just suck them in, and then we execute them on the endpoint. So the gap we're closing there is your SIM can already consume IOCs and help find where machines might be compromised. We find the machines that are compromised at the endpoint. So here's an example. It will seem familiar if you're paying attention to my MD5 use case. Here's that MD5. I've got a hit. But because I've scheduled this to run every hour, I've got other machines that are compromised. Here's my 3 compromised machines. So I'm going to look at this one, and you'll see here's my back off last malware file on disk. So we're finding the file on disk too here. And then here's some other things like registry keys. What are registry keys used for if you're a malicious actor? Persistence, yeah. So we'll find that. So, imagine the ability to ask arbitrarily, where does this registry key exist across my entire infrastructure? In seconds, you can have that answer. All right, so we got another machine. I'm going to walk through a couple more security use cases, a little bit of workflow here. We got a compromised machine IR demo. We're going to connect to it and now do some forensic investigation on it. So here is my I'm going to simulate it because this is a demo. I'm connecting to this one machine now, and I said that for some use cases, to SIR, we record data on the endpoint for use later. When I'm asking that running process question, I'm asking point in time, right? And if I schedule that to run every 5 minutes, what happens in 5 minutes? A lot, right? A lot happens in 5 minutes if you're a malicious actor. You can be in and out, snatch and grab. Or you can just be moving laterally to something else. So what we do is we put a recorder on the endpoint, we call it trace, and it traces the activity of the processes on the machine. Again, not a creative name. And so what we're looking at here is the activity that we've recorded at the kernel level without being a kernel shim ourselves. We're using tools that exist in the operating system like Sysmon's API to get virtual kernel access, and then we're storing that data local on the machine. We're not uploading it and all of your PII to a cloud. It's a stab. That's some other security vendors. So long name them. And if we look for that malicious process, oh look, there it is, because of course I planted it in this environment, but what we're going to do is we're going to find out in what context that process ran on the machine and when. So this is historical data we're collecting from this one machine, and we're investigating through the process command line. What launched that Java process? Well, here's our likely dropper. Here's the user context that it ran in, local administrator. So you probably got a compromised local administrator account. That's fun, right? What's that going to be used for? Potentially lateral movement, right? Here's some visualization, swim lane style timeline view of files that were dropped, like this one. What do we think this is? Where we're storing some environmental information if we're the bad guy in a log file, something that would fly under the radar. Maybe it's credentials. Maybe you're running Mimikatz here, doing memory dump and dumping that out the file. Here's our registry keys, or here's a registry key, our probable persistence mechanism. Here's some super suspicious looking command and control beaconing. Another process item here. If I look at the history, this is a timeline view down to the millisecond of what's happened after this process launched as a direct result of that process launching. This looks like any investigative tool that you probably have in your organization today. There's lots of tools that look just like this. But if I take any one of these items, let's say this is a unique key to my environment, and I want to ask a Tanium question, what other machines have this registry key ever written to their registry? Now I have the ability to instantaneously scope anything that's happening in my environment. Or who has ever talked to this IP address? Those types of things. We can save all these as IOCs and automate this process. So not only are we really good at, as a point tool would be, point investigation on a single machine, but we're able to instantaneously scope out any of these particular breadcrumbs across the entire enterprise. Who has ever had this bad attribute? Make sense? See some confused looks, so now's your time because I'm going to go into architecture. Any questions? Yes?
Sorry, unless I missed it before. All the processes are disk-based files or memory?
We are looking, I showed memory, but we can find files on disk.
Okay,
So
by default it's memory, right? So
by default, it's whatever you want it to be. I'll show you what I mean by that. But if I wanted to find files on disk, I actually wanted to play this one out. Oops, I shouldn't hit that. I'll come back to it. Here we go. Let's do that one more time. Get indexing. Index is a tool that we put on the machines. Let me do that one more time. Index is a tool that we put on the machines so that you don't do a directory walk or a recursive directory search when you're looking for files. We watch the file system and we record a very small subset of the metadata for each file that you want to search when you're looking for something bad. Like file dates, file hashes, file names, and locations. That's all we store. So if I wanted to find, hopefully you can see this. I don't have this planted in my demo, but I wanted to illustrate the capability. You want to find struts, jar files, or WAR files across your entire environment. That process takes seconds for us. And we're not walking the directory on each file system to do that. So that's a pretty recent painful example for many, right? Where is strut, Apache struts in my environment? And not only do I have the ability to enumerate the versions that are installed, because I did that installed applications, but I can also find the files if it's being used by another application as a component of that app. Sense? So yeah, file on disk, file in memory, sure, yes.
I was just wondering for malicious code injected in other processes.
Yeah, the malicious code injected in other processes, we have some tools that I won't go into here that will help with memory forensics. For example, you can use Tanium to do live recall memory searches across the enterprise. So I can find memory artifacts across all of the machines.
And then you can feed it to
Yeah, so that would be an example of how I play that use case out. Okay. Any other questions before I talk about architecture? Yeah.
You said it's all live now, but what about offline machines?
Yeah, so if I schedule a question to run, or if I'm running trace, that machine is recording with trace anytime the process is active. If the machine is offline, I'm going to ask a question every X minutes or hours or days to collect that data, and what I represent in the data set is, I'll just talk about it, I won't show it. The most current results from live machines and the last result from any machine that's offline. But fundamentally what you want to do with Tanium data, I won't demo this, is use Tanium Connect to feed the data sets that we collect out. As I said, we're not a single pane of glass. Most of my customers, what they will do is they will send the data that we collect out to another system for analytics. Usually a SIM, data lake, Elastic, things like that. Splunk, right? Make sense? All right. So I've teased you enough. How do you make this work there? The first time I saw this, I thought, yeah, sure. You're breaking the network. What's the impact on the endpoint? What does this look like? Did I hear Ferris wheel? Number one answer. Survey says number one. Yeah, London Eye I got once. What else? If you're a network guy, what does this look like? Network guy.
Spoken with.
Token ring? Yeah. The model that we use to build this, let's call it a botnet, white hat botnet, because that's what we're doing with it, right? We're controlling all the machines centrally, is Napster. Back in the 90s, we looked at Napster and thought, hey, there's an enterprise use case here. What is it? It's getting data to and from machines in real time by sharing the load. And so what we do is install a Tanium agent client on every single machine. And here's what happens. This machine comes online, it's a VM. Spins up, Tanium client's active, Tanium client reaches out to the Tanium server with FQDN and says, I'm part of this network, here's your public key, authenticate me and tell me where to go. And the server responds back and says, you are a part of chain yellow, actually chain 10.1.1.0/24, because your IP address is in that space, and your peers, your .6, your peers are .3 and .106. And that's this machine and this machine. Connect to them, stop talking to me. Now what I've built, when all of these machines connect to each other, is a chain, a linear chain, not a peer-to-peer, any-to-any network, but a linear chain based on IPv4 address in order, where only the first and the last IPs connect to the server. Why do I do this? Because I form a ring. Using one TCP port, for trivia's sake, it's 174.72 by default. You can change it whatever you want. We build a message bus through all the machines. It's actually machine-to-machine hopping, but that's not the point. So why? When I ask a question from the Tanium server centrally of all the machines, we don't connect to every single machine. We send that message to the leader of every chain. So one message per subnet. And then that message will get passed to each machine with the instruction, give me all of your running processes with MD5s. But we don't wait. This isn't token ring. The token has to continue, because this machine is an AIX machine, this machine with lots of horsepower, this machine is a Core 2 Duo with XP SP3 box. This machine is a single core server 2008 R1 machine that's going to take forever to, well, it's going to take seconds, which is too long for us to process that question. So the message is going to circulate. It's going to come around and collect answers. And everything that we're doing under the covers here is hashing everything we send as an instruction and signing that from the server, so you can't man in the middle it. And we're hashing all the results, so it's efficient. And there's a single message size, 64K, that we use for everything, or small, predictable. So one request out to the entire environment is no more than 64 kilobytes being sent once to each subnet across the LAN. Super simple, right? Why didn't I think of that? We do the same thing when we distribute content. This is where I'm going Napster, maybe BitTorrent. I'm going to use this botnet to get content out to these machines. Maybe it's a patch. Maybe I want to patch these machines for WannaCry. So those Windows patches that didn't get out there because SCCM failed, because it did. I got those calls that Saturday morning. I got lots of calls. SCCM, Altiris, BigFix, failed. There's gaps. Help me close them. So we said, sure. And this machine answers the question, am I missing this KB, this patch? What you would think is the server would send that to a local repository, and the local repository would make that content available because it was pre-staged. The machine would go to the local repo and get it. And you need repositories everywhere, not with Tanium. So we send the file to the leader of every chain once across the WAN. Then each machine in the chain caches that file. Why? Because the machine that needs it will extract it from cache and will execute it. The machine, this is an AIX machine. It's not vulnerable to WannaCry. Why would it cache the file? It does cache the file, but why?
Because somebody connected to it when he was up and down the
Because the
chain.
next guy that needs it gets it from the caches on the subnet. So we have a distributed repository across all of the machines on the subnet. And there's algorithms under the covers that make sure that cache is fresh, because machines are going to come and go. So here's what happens. This machine assembles that 80% of that file from all of its peers, 20% is missing. The server sends the diff to the leader to update all the caches and make them fresh.
Do you appoint the leader as part of the setup?
The leader is self-nominating, and if the leader goes away, this guy becomes the leader. And there's no additional overhead on the leader, because he just thinks he's part of the chain, but the next link is the server.
What about the cleanup?
The cleanup is there's algorithms that keep the caches fresh, and you can tune the cache size depending on different parts of your environment. Yeah, you can.
Because you don't want to.
Yeah, you don't want to put a cache on a machine that's got no disk. But guess what? We can ask every single machine, how much disk do you have? We can ask you right now. Who's got low disk? There's an ops use case that might be useful. If you're trying to do a Windows 10 upgrade, you're trying to push an ISO down to the machines, hey, guess what? We can push the ISO down and we can make sure there's space to do so.
So here's another. How would I work with the PBS Citrix?
We don't see inside if it's XenApp,
Yeah.
as an example, we don't see inside the container, we see the OS. So the visibility that we provide is to the host that's running the application on the user side, or to the server OS that's hosting XenApp, but not inside that application. We're not hooking it.
No. So how would we get inventory on those?
You would get inventory from the OS perspective on both sides. But, okay, let me hang on your question just to show one more thing is closed, because I think you guys are capable of understanding this, because I don't say that condescendingly. I did give this demo to C-level executives all the time. Usually they're just done at this point. That's even more technical than they're used to. But if I go into authoring sensors, this is back to the question about client impact. I think there are a couple of questions related to that. Sensors are what we execute when we ask a question. Get blah from all machines. That's a sensor. Blah is a sensor. Food. So running processes with, I don't know, let's pick SHA-1. Ignore the parameters at the top. They're not really pertinent to the conversation. This is what we're doing on the endpoint. We're running VB script, PowerShell, shell scripts, WMI queries. Here's a shell script. And we expose it too. So I have one customer that just took all of their PowerShell scripts that they use for forensic use on individual machines. I'm going to SSH to that machine. I'm going to run PowerShell. I'm going to do a remote command. I'm going to gather some data. I'm going to move on to the next machine. What if you could do that on all of your machines simultaneously? They just port them in. So if there's a use case where we can hook in maybe XenApp, and I haven't done that firsthand, but if you can script it to run on one machine, we can scale it. Any script that is in the languages that we support, and I haven't shown Python here, but we have that buried. Any script we can run on one machine, you can run on one machine. We can run on all the machines at will, in real time. So that if you look at the perfmon or procmon on a Tanium client, it looks like a heartbeat. because we're just executing scripts as you need the data.
Another security related question. So if everything relies on script, this means that scripting engines should run on all the hosts, which,
We execute the scripts natively.
oh, there are no active scripting engines running. So PowerShell is not running on it, it's not activated on the host.
We're executing PowerShell natively, as well as VBScript natively on Windows, yes.
Because otherwise it would be a platform for with like PowerSploit and
Yeah, we execute natively because there's that risk, yeah.
That is kind of a related question, because it's kind of you have a local copy of the script on every machine. You have a local copy of the script on every machine, because it's a.
I do have a local copy of the script
Okay.
on every single machine,
Okay.
and its hash representation, yes. And that process is synchronized with the server. So every 4 minutes or so, each client will check in with the server and say, are there any new sensors that I need to know about that you're expecting me to execute? If so, send me the hash and the text representation of it out of band.
In fact, my question more related: if hacker have access to this machine and can modify the script, but actually, if you have hash,
Well, if
You can
the
detect it.
client controls that caching, and if that script is not signed by the server, it's dumped. So you can't man in the middle of that. Take me at my word for that, but
No.
we've had to go down that road many times. Fair question. That's how it works. That's what it does. The other thing that's different about us as a software vendor is we like to POC a lot at scale. Because I can show you in a POC where you've got gaps, where you've got vulnerable Java Flash, critical vulnerabilities missing, struts. We can see that in a POC. And you can't throw me a more complex, larger environment than the Air Force, and they're public about using us very widely. So, that's it. Any questions? Fire away or grab me offline. Oh,
Question. Can you replace Windows Update Services role with this tool?
We leverage it to do what we do. When we're doing a patch scan on a machine, you can either use Tanium to deploy the WSUS offline CAD file, and we can execute an enumeration process to compare what's in that file versus what's on the machine. Or you can point machines to a WSUS server or to Microsoft, or all three, depending on your environment. I have a customer that does that.
But
Yes.
you can do it manually. Just extract those.
We
packages and-
have to use the Windows Update mechanism in order to get that job done, but we have no reliance on external tooling like SCCM or external WSUS. We do the actual patching process ourselves. Make sense?
Yep. How do you license this?
Per endpoint, per operating system is probably a better technical description. So you spin up a VM, that is a unique OS, it has a Tanium client running it. That's one license.
What's the form of the server? Is it the virtual appliance? Is it
We have,
cloud-based?
you can virtualize it up to a certain scale. But one thing I glossed over, didn't talk about, is there's one Tanium server that controls the entire environment at any scale. I've proven that myself. So it's usually a big box because it's got to handle as many connections as you have subnets. So I'll give you an example. A customer of mine in manufacturing conglomerate space, 400,000 machines, they have one Tanium server. Well, I have two, they're HA clustered, that controls the whole environment. There's no distributed relays or repos or anything like that. It's Gen 8 Xeon 64 core, half terabyte RAM. We do everything in memory, so we need a lot of RAM. You can virtualize up to about 35,000 endpoints. We also have a Linux-based Tanium server that runs on an appliance. Fundamentally, historically, we're a Windows Server application.
Is everything push or can you, is everything pull or can you push? So for example, can I schedule one of the agents on these strings to let me know if there's a particular event, or do I have to vary on a regular basis?
So really good question. Up until the end of this month, the answer is it's always push. At the end of this month, we're launching Detect 3, which has a concept of endpoint policy and alerting in real time. So keep your eye out for Detect 3. Yeah. Good questions. Any others? Okay, thank you for your time.